All right, so we will start our lesson today. Okay, so today we will in this I think about 30 minutes or 1 hour. Okay, we will continue the things that we done yesterday. Okay, there are a few stages that we have to perform after we normalize. So yesterday we already up to normalize. Okay, so we already select our features. Okay, so in column filter here. Okay, so we already select the features that we want to use to predict the price. And make sure when you perform a column filter, when you apply this column filter node, okay, it's include together all the output or response variables and also all the input features that you are going to use, okay, to train the algorithm, okay, to train and to validate. Okay, so these input features, we are going to use these as the input values to predict the price. Okay, so up to this stage, I think shouldn't be a problem. Okay, all right. So the next is we normalize, okay, because after we check this table, okay, we found that the value are not consistent. The consistency of the value are not same. Okay, the magnitudes are not similar. So we want to make sure the range of the, in the range of the value for the features or for the input, they are in consistent range. Okay, so what we do before is to have a normalizer. Okay, so we normalize, okay, the input features here using min and max normalization. So the values for this table later on will be updated. Okay, this one will be updated. Okay, so that, okay, the maximum range of the data table for the input features, okay, is between 0 until 1. Okay, so that happened there. All right, and then we don't have to normalize the price. Don't ever normalize the price. Otherwise, we will do denormalization later on. So that it's time consuming, and then you have to introduce another nodes which definitely increase the size of your workflow. Okay, so having a having more nodes means you introduce a series of code, okay, a series of code in your workflow, and it definitely affecting, the size of your file workflow. Okay, you still remember the KNWF, that file, okay, the workflow file. So that one will be affecting later on. Okay, so so after we do the normalization, so the next stage is more into what do we call partitioning. Okay, so partitioning, so after normalize, the data now is ready. Okay, after normalize, the data now is ready, so we have to partition the data set, okay, using a partitioning node. So just type partitioning. Okay, use partitioning node. Okay, so we will partition the row in our data set into train and test set. Okay, right, so if you already done, okay, should be good. Okay, because yesterday I asked you to do it. Okay, so make sure if you are, I hope you will in the same track with me lah. Yeah, okay, so the partitioning mode here, okay, I use, okay, in this case maybe I want to choose 80. Okay, I want to choose 80. Okay, 80% to train, okay, to be used as a train set. Okay, and then another 20% I use for a test set. So that's are the things that I'm going to apply here. Okay, so or maybe we fix with 70 lah, because the data is, if I use 70, I think 70 is much better. Okay, the reason is I want to have more data for validation later on. Okay, I want to have more data for validation, but you can always try 70, 20, 70, 30, 80, 20 also can, doesn't matter. Okay, in this case I use 70. Okay, and then I draw it randomly. Okay, the same things in regression problem, we can draw it randomly. Okay, doesn't matter. So we can draw it randomly. And then the next, we set this as 0, okay, so that the method, okay, when the partitioning happen, okay, it will start from a 0 point in this data set, okay, which is determined by these nodes, okay, the seeds. Then we click apply, right? Okay, so we click apply. Okay, now we have two partitions here. The first partition containing 70% of the data set. Okay, so another 30% is allocated at the second row, allocated at the second partition. Okay, all right. Okay, next is to continue the workflow to train the algorithm. Okay, after we do the partitioning, okay, so we are going to train the algorithm. Okay, so because we want to predict the numerical features, okay, so we have to use a linear node, linear learner node. Okay, so linear regression learner node. All right, so we have to use this. Okay, so okay, learner node. So we are going to train the OLS algorithm using a linear regression learner here. Okay, so just drag it. Okay, just drag it. Right. Okay, and then configure it. Okay, this is important here. Okay, when we do the configuration, okay, so which one that we want to target, which one that we want to target. So what is the output variables? Okay, so we know that we want to predict the price. So price is our response variable. So we have to choose price here. Okay, so automatically the price will be removed from these boxes. Okay, these boxes is to indicate that all these to become a input features later on. Okay, they will be used as a input features. Okay, so nothing else. This is not significant. Okay, this doesn't affecting any of our models. So click apply, right, and click OK, and then execute and open view. Okay, right. Okay. Right. So now we have this model. Okay. So we have this model. Okay. So all these are the coefficient. Okay. All these are the coefficients of each input that we have. Okay. All these representing the coefficient. Okay. The interpretation is also similar with what we have done before, the example yesterday. All right. And we saw here, the most important is we want to know whether the model have a good performance or not. Okay, so as you can see here, the adjusted R squared, okay, it gives me about 0.83 or at 0.84. Let's try to take a look into the slide where I already run it. I think it's almost similar. Okay, it's slight different. Okay, it's slight different, doesn't matter. Okay, so you see here. Okay. All right, so you always can play around with the number of partitioning. Okay, whether you want to partitioning the data set 80-20. Okay, you can always try and narrow. So you always try and change the value. Okay, which one is suit for you. Okay, but it will not affecting much. The things that might affect is if what happened if I introduce, okay, what happened if I introduce a new variable. So that might be a little bit things that might affecting the value later on. Okay, all right, so this is the first way of evaluating the model. Okay, so we summarize, okay, the statistical information about this linear regression. Okay, from here we got the coefficient, the standard error, and also most important is the R squared values over here. Okay, so from here it's quite strong, okay, indicating that all these inputs, okay, all these inputs has a good, okay, has a good predictor, okay, to predict the price. Okay, they can behave as a good predictor to predict the price. Okay, so maybe in the future I want to add, there is a one more variable that can be added. So we are going to take a look into that later. Okay. All right, so the next is to apply the model. Okay, so to apply the model, you have to use a predictor node. Okay, so we have to use the predictor node. Okay, so the predictor node is available here. Okay, so regression predictor, because this is a regression problem, so we have to use a regression predictor. Okay, we cannot use other predictor from the other algorithms. For example, if you take a look analytics here, go to mining and then search for, yeah, hello, yes, all right. So okay, so for example, if I go to the Bayes model, so Bayes, okay, naive Bayes have their own learner node, and naive Bayes also have their own predictor node. Okay, so each of these have their own predictor and also learner node. Okay, all right, so now we know that the output of this linear regression learner node is the model. First, we have the model. Second one is the coefficient value and the statistical information. Okay, so if I right click and then go to here and we'll give, it will summarize all these coefficients, the same things that we visualized before. Okay, so the next is we connect, okay, because we want to do a second validation, whether that model is really good or not. So we perform a second validation method where we compare the correlation between actual output and also predicted output. Okay, so in order to do that, we have to apply, okay, the data set that containing known output. Okay, so the model will predict based on the input that we have, and then they compare the prediction values and also the actual value. Yeah? Okay, so take a look here. Okay, maybe we can, okay, this one we untick because we want to create a new data table, okay, a new column that containing the prediction price. So later on, I can do what we call as the correlation test, okay, between this data set, okay, between prediction price and also the actual price, okay. All right, so we click apply, right click, okay, and execute. Okay, so from here, we will get, okay, so you see here there is a price, okay, sometimes it's quite far. Okay, you see this is actual price 13,000, but the predicted price is 16,000. Okay, some value they are quite close, for example 20,950, and then this is 20,000. So you see there is the value is almost close to each other. Okay, but of course in some cases they have some error. Yeah, okay, they have some error there. Okay, even if we want, okay, if I want to see the differences, maybe I want to see the differences between the actual and what we call actual and also the predicted price. Okay, I can use math formula, for example. Okay, this is extra. Okay, so just click math formula here. Okay, and then we can drag it here, and then we perform. Okay, for example, I want to see the predicted price. Okay, I want it to be an absolute values. So there must be an function absolute here. Absolute. Okay, let me take a look. That should be under data absolute. ABS. Okay, usually that is named as ABS. Okay, so I will absolute the value. Absolute means that if small value 1 minus 2, so it will give you 1 instead of -1. So that's why we want to get the absolute values. Okay, so in this case, I find the absolute values between predicted price, okay, so minus price, okay, so I can get the differences. So maybe I want to check how much it differ compared to the actual value. Okay, so what I can do is I can divide it with actual price. Okay, I can divide it with actual price. To get the percentage different, so I can multiply it with 100%. Okay, and then we multiply it with 100%. Okay, and then percentage different, maybe symbol percentage here. I think we cannot use symbol. Percentage difference. Okay. Okay. All right. So maybe let's try and see. Okay. I do it also spontaneous. Okay. Spontaneous. I do it. Okay. All right. So you can see here there is a. Okay. You can see the value of differences here. Okay. If you use more better mod, if you want to find the maximum value, also you can perform a statistical analysis here. Okay, using a statistics node. Okay, we always can use data exploration nodes. Okay, to determine the maximum difference. Okay, so you also can get it here. All right, so it depends on your creativity whether I want to see the difference, percentage difference. So everything can be used. Okay, as for you to validate the model. Okay, so using our conventional method, we can find the correlation. Okay, so use the linear correlation node here. Okay, use the linear correlation nodes. Okay, so from here I want to determine the correlation between price and also prediction price only. Okay, so click apply. Okay, and then execute and open view. So we can see that the correlation is 0.912, which is quite high. Okay, I believe it's quite high. Okay, it's quite high correlation here. Okay, if you can see here 0.91. Okay, and the p-value here indicate that it's very significant. Okay, it's very significant. Okay, so let's try. Okay, visualize it using view, use a scatter plot. Okay, use a scatter plot and then validate the model. Okay, we want to use a visualization method to validate the model. Okay, so price, okay, versus predicted price over here. Click apply, okay, right click, execute and open view. Okay, all right, so you see here, okay, so these are the values that the trend of the graph that we can see here. Okay, so by right, if you plot the straight line, okay, if we plot the straight line to show the relationship between price and prediction, that line should be almost 45 degrees. Okay, the 45 degree almost. Okay, maybe plus minus 2 or 5 degrees, something like that. Okay, so it must be 45 degree. If even you see here, you can take imagination that the straight line have to be 45 degree. So that is the things. Okay, if you want to compare the correlation between predicted price and also the price using a graphical method. Okay, scatter plot. Okay, all right. Okay, so that's it for okay, so now let's imagine that we are agree with this model. Okay, so I believe that this model has a good performance to predict the price of the car. Okay, we agree on that. Okay, so the next stage, what is it? Okay, how do we apply it? Okay, so what we can do on it? Okay, what should I do with the data set and with the model? Okay, how about if I want to go to apply to build the apps based on this model? Okay, which should I copy it as a workflow? Okay, or I need to save it. Okay, so we save that model into a model format. Okay, into a model format. So in KNIME here, we can write that model. Okay, there are two nodes that usually use to write the model. Okay, so if you want to write the model, so you have to go to input and output group workflow. Okay, group workflow. Okay, inside here you want to write, right? You want to save that model. Now the model is here, and then the model is coming from this output port. Yeah? Okay, so look for the right group node here, and then you see. Okay, if I want to write the data table, I can use CSV writer, I can use table writer, or even I can use Excel writer here. There is Excel writer here. Okay, Excel writer here. Okay, so now we want to save model. Okay, so we have to use a model writer. Okay, another one we can use PMML writer. Okay, some people, they use PMML, but sometimes you cannot use PMML because the transformation that you've done earlier doesn't match with PMML format. Okay, for example, if you use missing value nodes, and then you want to remove the rows that containing missing values, so that kind of imputation, okay, we call this imputation, will change the format. So means that it cannot be used as a PMML format. Okay, the data table resulted from that action is not in PMML format. Okay, so in this case, the safe, okay, the most safe condition to make sure everything is smooth. So I can use model writer here. So drag the model writer here. Okay. Right. So this is model writer. Okay. So you see here, this kind of connection, even they are not the same, what do we call? They are not the same color, but they can be connected together. Okay. If later you have new data to predict, okay, I will demonstrate that after we finish to save the model. Okay, Helmi? Okay, there is a section I already have here. So saving the model and then apply with a new data set. All right, okay. All right, so now I want to save that model. So we have to connect it to here. All right, we have to connect it here. Okay, so the model writer, so the same things as what you want to save in the, what do you call, in the CSV file, yeah, in the Excel file. Okay, you have to search where do you want to save it. Okay, so I want to save it at desktop here, and then look for the folder, your folder just now. I use a machine learning folder, and then I can name that file. Okay, so maybe I name it as what do we want to, car predict. Okay, car predict model, something like this. You can name anything. You can name anything. Yeah. Okay, you can name anything, and then click save. Okay, so click save and then click apply. So now the node is ready to write. One more thing, yeah, one more thing. To avoid error, maybe next time you're updating the model, okay, and then you want to rewrite that file again. So click overwrite here. Okay, you can always overwrite that particular file every time you updating your model and you want to resave it again. Okay, so click apply, click OK, and then right click and execute. Okay, so now we have the model already. So where is it? Okay, let me show with you. Wait. Yeah, okay, go here. Okay, so the name of the model, wait, use group. So the name of the model just now is this one, car predict model dot model. So this is the name, the extension type of the model saved from the KNIME. Okay, so this is the model. So in the future, if I have a new workflow, okay, I give you this file folder. I give you to this folder, and then you can use this, okay, to do the prediction, as long as you know what should be the input values there. Okay, you have to know what will be the input values, the suitable input values to be used and apply into the model. Okay, so these are the things that we can use up. Okay, so open this one first. Okay. All right, so now the model has been saved. Okay, so as Elmi asked, okay, so what happened after we save the model? Okay, after we save the model, so what happened? Okay, all right, so later on the saved model can be used for a production. Okay, you want to develop the apps. Okay, that is, you have to learn another architecture of how do we deal with this model, this machine learning model. You can use a lot of frameworks to work with that. Okay, so the next is, how about if I want to apply this model into a new data set? Okay, into a new data set. Okay, so you see, if I want to save, I use writer node. If I want to import, I will use reader node. Okay, so Last time when I want to import the data set from Excel file or CSV file, I use CSV reader node. Now, because I want to import the model, I have to use a model reader node, okay, which is also available at IO group node under read, okay, under read. So where is it? Okay, all right, so we use the same workflow. Kita tak nak buka banyak-banyak, okay. Even if you want to open the new also can, but I just continue it from here, okay. So that reader node is available here, okay. Read, so you see here, this is the model reader, okay, the model reader, okay. So here you can import it, but let's get back into the example. Okay, so what we want to do is I want to predict the car price for a new data set. For example, I have a new data set. So I have, I believe you already have this new car price. Okay, so try to open. Okay, let me open. You don't have to open it. Okay, let me open. Yeah. Okay, so you see here, this data set, okay, I have one column with a car ID. Let's say this is car ID, car 1, car 2, car 3. Yeah, this is the ID and it must be unique. Okay, so, but from here, you will find that I don't have any column on price. So the reason we have this predicted model is to predict this kind of data set. I have a new coming data set, so what I can use later. So I have to use I will use it to predict this new data set. So from here, I can estimate what should be the price of the car. Okay, so how do we do that? Okay, so we have to import these data sets. Okay, so we have to import that data set using a CSV reader nodes. Okay, just copy from what you see. Okay, what you already have here. Okay, so CSV reader, and look for the new car price. Okay, new car price. Okay, new car price. All right, so the rest, okay, we leave it like this. Okay, it doesn't matter. Okay, so we just leave it here. All right, I think it's follow the similar. Okay, so no. I don't want to use this one. Delete it. Okay, we use the new one. We need to use the new one. I don't want to override some of the same the transformation that I have made earlier. Okay, I don't want to rewrite that. Okay. All right, so call the CSV reader. Okay, and then search for the machine learning, and then search for the new car price. Okay, new car price. All right. Okay, so in this case, okay, in this case, all this data set already been, they have already in appropriate data types. Okay, all the numbers should be integers or double. Field type is in string. Okay, so now we introduce this one, this data set. But later on, I want to save this. I want to know the index of this car, the ID of this car. So we can directly transform this into has row ID. We can use set row ID, introduce a new node, or we can directly. So now we change this into a row ID. Okay, or you want to, if you want to use the apa nama tu? If you want to use the set row ID also can, or you want to transform it here also can. Okay, and if let's say you have a double, okay, if you have repeated, I mean, if you have duplicated row ID for this column, so it will be an error. You cannot execute it even. Okay, so apply it. Okay, has row ID. Make sure you tick this one, and then click apply. Okay. So why we have to change this into row ID? Okay. So the reason is because I don't want my when work in the next workflow, I don't want it to consider this as a data point. This is not this is not data point. Okay, this is data point, the things that related when I want to do the modeling. Okay, so only these are the importance data point to be used. Okay, so this one is just an ID of the car. Okay, all right. So when you want to do the prediction, also you see the data set that you have here. Okay, if you take a look properly, so some of the variables that we know that initially we don't want that to be used as a input values. Am I right? Okay, we don't want to use that as input values. Okay, so what happened here is we have to do a little bit transformation. Okay, little bit transformation and filtration here. All right, so the first thing is, okay, I can start with by transforming this categorical variable into a numerical variable, okay, into a dummy variable, right? So in order to do that transformation, I can copy this. Okay, actually, I can copy these three things directly because this is the important stages to ensure that the data set are similar with the one that we prepared before. Okay, so copy these three things. Okay, so just apply it here. Okay, so when I run this, because the features is almost the same, so you see these are the things that we need to be similar when I do this comparison. Okay, so this is from the one that we want to predict. Okay, so you see here, okay, all these input features we have already here. Okay, same also the one that we have here, only this one, because we use it to predict the model. Okay, to train the model, so we have price. This one we don't have price, that's why we want to predict it. Correct? Okay, so means that I can use this as an input values later. All this data set will be used as input values. Okay, all right, so next, okay, so now we want to apply it into a model. Okay, we don't have to partitioning it. Okay, so tak ada issue partitioning dekat sini because it's not training the algorithm, it's applying the model. Okay, it's apply the model. So in order to apply the model, so we have to use a regression predictor. Okay, we have to use regression predictor, the one that we use to apply the model here. Okay, all right, so the regression predictor here, we know that it has to receive a, excuse me, okay, it has to receive the input data, okay, all the input variables that we are going to use. Another one is a model, correct? Another one is a model, but now we don't want to drag it from here. We want to use the model that we already set. Okay, even I can drag here, also can, boleh juga. Tapi saya nak tunjukkan how about if I want to use the model that I saved before. Okay, the model that I saved. Okay, so import the model means that we use a reader node. Yeah, a reader node. Yeah, so we use a model reader. Okay, so we put it on top here and then connect. Okay, even we don't have to connect yet. We find where is the file. Okay, so go to, I put it in desktop under machine learning, and then so is it the one that I made before? Is this one, if I'm not mistaken? Yeah? Okay, Friday today, this one. Okay, so this is the model that I saved before, right? And then click open, click apply, and then click OK. Okay, click apply and click OK. Right, so now I can import that model. Okay, you see the data table is not a data table, it's the model in terms of this is the way how it's saved in our workflow, in our workspace, sorry. Okay, so it's in the form of this data lah. Okay, so now we want to import, we want to inject that model into this predictor node so that it will be applied into the data set that we already prepared. Okay. All right. So now we have to provide the custom prediction name here. Maybe we make it better. Predicted price. I prefer words predicted price. Okay. Right. Okay. And then click apply, click OK. Right click and execute. Okay. All right. So if I execute now, I have this value. Okay. I have all this. Yeah. I have all this. Okay. So I have the predict. Okay. With these input values, so this is the price. With these input values, with this is the price. Okay. So I have the predicted price. So what do you think else that might be needed here? Okay, so do you think that this data is relevant or how? Okay, let's say you want to save this into a spreadsheet file. Okay, and you know that if I save it, if I save this data, what do we call? If I save this data table, I will get the value in normalized value, this one. Okay, so you will get this normalized value. Okay, I can use a denormalize command. Okay, I can use that, but in this case, I will show you another shortcut. Okay, another shortcut where you can reduce the number of the nodes. Okay, so first, I just want to collect this. I want to filter this one. I just want to ambil yang predicted price saja. Okay, I want to take only predicted price column, so I can use column filter. Oops, sorry. Column filter. Yeah, column filter. Okay, guys, tekan ni okay tak? Boleh? Any question up to this? Okay, boleh follow Okay, alright, okay. Okay okay, good. Yeah. Okay, yang lain okay tak? Kevin, Ahmad, Sophie, Cindy, Elvin, Aswadi, okay. Catherine, yeah, okay, alright. Okay, nice, okay. Alright, so yeah, alright, thanks, okay, thanks, okay. Okay, so now we predict. Okay, sekarang ni saya nak ambil, I just want to take this one. There is a reason because I don't want to have this column. Okay, but I want to have this column, tapi at the end of the day, saya nak save satu Excel file or CSV file that containing car row ID dengan data-data yang sebelumnya. Okay, so what I can do here, first I filter the column, so use the column filter. Okay, I use the column filter as a deployment. Yes, we can say that. Yeah, Sophie. That's correct. We can say there are a lot of ways of deployment actually. Some of the method of deployment is, okay, you create your website and then the input value through the website, itu pun boleh. You build the apps. Okay, ini kita deploy dia dekat kita punya workflow. Okay, so this is considered as a deployment. Okay, maksudnya I have the model already and I deploy. So at the end, my goal is to get the spreadsheet that containing the card ID with all those features and then with the dia punya predicted price. Okay, so this can consider as a deployment. Okay, so we deploy the model. So another stage of deployment, for example, you have to build the end products. Okay, but you have to integrate the model. You use the appropriate kita panggil frameworks lah. Okay, Flask. Okay, they are any other things that you can use, okay, to ensure that you can deploy that into a services. Okay, ada yang buat machine learning model into a services. Okay, alright. Okay, so column filter. So I only want to take a predicted price. Okay, so click apply, right click and execute. Okay, so these are all the predicted price that we have before. So together with the row ID. Okay, together with row ID. But one thing that I'm curious here, I want to nampak 3 decimal places. Paling-paling pun duit shilling ada 2 decimal places lah. Okay, so I want to round this value into, maybe you want to round this into integer pun boleh. Maybe this time we round it into integer. Okay, dalam example saya round into a double, okay, with 2 decimal places. So I want to round it into integer lah. Okay, so to round it, I can use maths formula. Okay, I can use maths formula. So you see, every time when I want to do the mathematical operation, okay, you want to use a mathematical function, I always use maths formula. Okay, saya selalu guna, memang maths formula je kita boleh pakai. Okay, so drag it, okay, and then go here. Okay, so tadi saya nak saya nak jadikan dia sebagai integer. Okay, so I can directly just convert to integer, something like that. But we use satu method kita panggil sebagai mana? Dia ada round. Okay, we use round. Okay, round into integer. Okay, so we roundkan value ni into integer. Okay, so we round that. Okay, so we replace the column. Tak payah buat column baru. Okay, replace that column. Okay, and then click apply. Right? So right click and then run it. I believe we will get integer value. Oh, tapi data type dia masih double. Okay, why not we change also that data type? So just click convert to integer. So that data type will be in the form of integer. So dalam bentuk integer, lagi senang kita tengok. Okay, lagi senang kita tengok. Right, okay, so the next stage after we convert that.
Sorry, doctor. Yes. Can you repeat again the last part?
The last data part, type. Ada this one,
yeah, okay. The data type, yeah.
All right. So you click this one. Okay. Now we want to round this column. So we use the round function here. Look for the round function here. Then double click the round. Okay. Yeah. And then you make sure this is inside, and then use convert to integer.
I see. Okay. I missed that. Sorry. Thank you.
All right. No problem. Okay. Yeah. All right. Okay. Yeah. Okay, so now we have this. So sekarang ni, this is the price, and this is our original data set. Okay, which doesn't have price. Okay, oops, sekejap ya. Ni dah tak pakai. Okay, I want to ambil ni, letak dia dekat tepi ni. Okay, I want to use this and then put it beside here. Any suggestion? What is the best? Yeah, what is the best method that we can apply here? Apa notes yang paling sesuai? Okay, to perform this action. Okay, this action. Okay, boleh guna join. Okay, boleh guna join. Alright, so you can join it. Okay. So in this case, if you want to join, you can join kan dia based on row ID lah, pun boleh. Okay, and also I can join it based on apa nama ni? Saya boleh gunakan column appender. Okay, you still remember the join and concatenation? Okay, in this case saya boleh gunakan appender juga. Okay, so join kita dah tahu, kita boleh gunakan join kat sini. So in this case, saya nak gunakan satu lagi notes baru, kita panggil column appender. Okay, so we go to here, search for column appender. Column appender. Okay, column appender. Okay, take your time to search for it. Okay, so dia dalam split and combine because we want to combine 2 data table right now. So one of the ways is to join, to use a join. Another way is use a column appender. Okay, so kenapa saya boleh gunakan column appender? Because you see, the row ID right now is follow the same sequence from start to the beginning. Kalau dia tak follow the same sequence, so you can use join. Okay, you can use join. Okay. Oh, okay, Akmal. All right. Okay. All right. Okay, almost 1 hour. Yeah. Okay, please watch the video. We are almost finished in this part. Okay. So this, by the way, it's easy. It's not that heavy. I think you can take a look at the video lah. Okay. All right. So, all right. So here you see we can append it. So because it's the same sequence. Okay. The data right now is in the same sequence. Okay, so how do we do the append? So use the column appender. So the first table is, okay, I want to use this. I want that price to be appear at the last one. So this one to be a left table. You still remember left and right table? You can do it vice versa, doesn't matter. Okay, you can use, doesn't matter as long as the price column appear. But in this case, I want that price to be at the end right, okay, the right end of the data table. So I use the CSV, the data table from here as a right, as the left table, and then the data table here as the right table. Okay, so do some configuration. Okay, generate new row key, tak payah. Okay, so the row key will be identical. Okay, and then click apply. Okay, and execute appended table. Yeah. So now I have the original data set that I have with the row ID, and also I have the predicted price here. Okay, I have this predicted price. Okay, cool, eh? Okay, the next is to save this file. Okay, saya nak save file ni pula. Okay, so what we can use? Okay, what is the suitable? Okay, suitable apa nama ni? Suitable notes to save the file. Let's say I want to save in Excel. Katakanlah saya nak save dalam Excel. So search for the writer note. Okay, so search for the Excel writer. Okay, because we want to save that file. Okay, the data table. Okay, so take it here and then drag it here. Okay, so Excel writer is straightforward. Okay, cuma ada beberapa benda yang saya nak bagi tahu kat sini. Okay, so we can use this format, okay, as Excel. So tadi kita tengok dekat sini this data. Okay, we have the ID, right? Okay, so this row ID is the car ID. Okay, so in this case, I want this row ID to be saved, okay, as a data in my Excel sheet. Okay, so that's why we have to take right row key. Okay, right row key. Okay, ini mestilah right column header sebab dia ada header. Kalau tak, dia tak ada keluar header. Okay, so we have to write it. Okay, and then where do you want to save it? As usual, I want to save it here lah. Mana dekat mesin sini. Tuan-tuan dan puan-puan, just save dekat apa nama ni, dekat desktop pun boleh. Okay, so predicted, name it as predicted car price. Okay, you name it anything. Okay, apa je yang tuan-tuan dan puan-puan nak namekan dia. So I name it predicted car price. Click save. Okay, and then make sure you override it. So in the future, ini terpulang lah, you nak override. Tapi kalau saya rasa ini bagus saya use this method because sometimes kita nak buat new, contoh saya nak buat prediction, right? Okay, I want to make a prediction. So kalau saya override, saya gunakan nama file yang sama, wah, nanti dia kacau benda yang saya dah predict sebelum ni, hilang file tu. So we want to avoid that, so we can use, okay, instead of write, so we use this notation. Okay, so that is the best way. So that's why they have this selection in the notes. Okay, all right, and then right click and execute. Okay, and then cuba tengok dia punya ni. Okay, I put it here. Apa nama dia tadi? Ini dia. Okay, car price.xlxx. Okay, so double click on it. Okay, so now we have, okay, ini dia punya row ID tadi, dia punya age, okay, everything. Okay, for this new predicted Excel sheet. Okay, so we have ini adalah input. Tadi ini adalah dia punya features lah, and this is the predicted price. Okay, so everything is better right now. Okay, all right. So yes, so we complete this linear regression. Okay, so far. Okay, so we have another 2 algorithms that we are going to finish today. Okay, and this later on is more on application of that algorithm, and some part of this can be replicated. Okay, saya tak boleh, kalau kita tunjuk, kita perlu 2 hari lagi. If I show every example using okay, how to save it, how to ini, sebenarnya proses dia sama sahaja. Okay, the process, everything is still same. Cuma if you need another information, you can always use other extra nodes as I mentioned earlier. Okay, so banyak benda yang kita boleh tengok lagi. Okay. Alright, so okay, so without further, okay, kita rehat selepas kita buat lecture sikit nantilah ya. Okay, I think 9:30 lah. Hopefully 9:15 maybe something like that. Okay. Alright, so far boleh ya? Okay ya? Right, easy ya? Okay, so you see compared to the Python previously ya, Python ya, kalau nak deploy like this, okay, this is totally easy. Okay, if you took the class with me before to learn machine learning with Python, so you still remember the last part, okay, where we want to apply the model, so we have to search the code. But of course, give and take lah, depend on individual, yeah, independent individual. If you just started to learn data science and then you learn Python, so you will invest a lot of time to learn the tools. Okay, so if you just knew and then you use this tool, okay, so you know it once, later on you already understand, okay, this is the node. The things that limit the process is, we can say, our imagination, okay, because everything already here, the workflow, the nodes, yeah, okay. And another cool features that I want to show to you, okay, but maybe I can demonstrate. Yeah? So let's say you want to find some sort of nodes. Okay, so this is my okay, so you can search for the KNIME hub. Okay, in KNIME hub here, there are a lot of nodes collection. Okay, there are a lot of nodes connection. Tapi tuan-tuan dan puan-puan jangan ikut dulu apa yang saya buat, sebab saya takut nanti dia akan create error in some computer and sometimes lag. So jangan ikut dulu. Okay, so in the KNIME hub here we can find workflow, nodes and component. Okay, contoh apa ya? Saya nak cari dulu. Ada tu saya ada cari something. Okay, maybe looping. Okay. So I want to use, okay, maybe network looping here. Okay. All right. So some of the nodes, okay, you see this node, yeah? I can drag it directly from here until here, but we have to understand, okay, why we want to use the nodes. 1, 2, 3, loop. Okay, I click yes. Okay, so you see here, we can use this node directly. Okay, so please jangan do anything here. So you can always search for the node and import it here. Okay, kalau ini saya rasa ini adalah workflow. Okay, ada certain things adalah node. Contoh node tu ini database. Okay, maybe this one. Okay, this one is more into, I think, this one is nodes. Okay, so I want to use these nodes, so just drag it here. Okay, so I can use it further. But you have to know what the things that you're looking for. Okay, so this is one of the cool features lah. Okay, kalau kita buat Python programming, right? Apa yang kita buat adalah cari dekat GitHub ataupun kita cari dekat apa nama tu? We search for the code in the Stack Overflow. okay, Kaggle, we copy and paste, Control C and then Control V. Kalau ini you drag and drop the node, sama juga. Okay, but maybe some of the nodes dia taklah banyak sangat tapi ada lah, okay, some of them there's quite a big community here. Okay, so there is a lot of nodes, okay, tengok macam ni. Convert matrix to table, okay, even principal component we have here. Okay, and if I don't mistake, I received some about Monte Carlo. So try to Monte Carlo. I'm not sure we have it here or not. Okay, so yeah, time to string. Yeah, Monte Carlo. Monte Carlo. I think the problem that you have to design your own workflow on that. Okay, yeah, kita customize. Yeah, this is the things that been apa kita panggil? Dia banyak contributors tau. Even kita pun boleh. Contoh, you guys have your own solution for this problem. So you can upload your nodes dekat sini, but you have to register as developer. Okay, alright. So ini adalah more into ni. Dia buat jalan kerja. Yes, some of them already been okay. Ini nodes. Contoh, kalau saya nak search for workflow, kalau saya nak search for component pun boleh. Komponen ni ingat tak yang kita buat sebelum ni? Ya, kita boleh buat komponen and even share. Okay, so workflows. Okay, ini workflow seperti yang saya cakap tadi lah. So a lot, sangat banyak lah. Banyak. Okay, so this is more into customize. Yeah? Okay, this node can be saved into our KNIME and reuse. Yes, correct. Okay, so kalau kita dah letak sini, okay, we just save, dia dah dekat kita punya sistem. Okay, components yang kita combine. Yes, that's correct. Okay, component is more into the interactive version that we done before. Okay, benda yang kita buat sebelum ni. Okay, so yes, we can save it here. We can always use it in the future after we save dekat kita punya workflow. Okay, so that is the advanced feature on using this. Okay, alright. So dia dekat KNIME Hub kita panggil KNIME Hub. Okay, sama. Kalau Git, kalau programmer ataupun Java GitHub. So sini dia ada dia punya sendiri KNIME Hub. Okay, yeah, okay, easy, right? Okay, ini kita tak pakai, kita delete lah ya. Kita delete, okay, so the next thing, okay, so yes, this node can be saved, yeah, correct, okay, and it's been curated tadi macam beritahu, so it's curated by who? By the contributors. Okay, by the contributors. So we can always contribute, but we have to register as developer if I'm mistaken. Okay, can we enter a new chapters? Okay, lepas ni ada satu lagi dan we complete lah our lesson. Okay, alright, classification model. Lepas kita habis sesi lecture ni, kita boleh rehat. Okay, mungkin 10 minit macam itulah. Kita boleh rehat and then we continue again. Okay. So classification model. Okay, tadi kita buat sebelum ni, sejak dari semalam, what we predict is the what we call as numerical features and numerical response. Sorry. So we predict the price of the house. Okay, we predict the stock market. Okay, so the value is in a numeric values. Okay, so for example, in engineering, if my side, I know we predict the strength of the concrete. Okay, we predict the deflection of the beam. So that is the things that we do the prediction. Okay, so my students also they use this KNIME as untuk dia buat concrete. Okay, so you see these 2 years because students are not allowed to come to the lab. Okay, and we want to limit this kind of interaction. So what they do is most of their project is more into programming, machine learning. So we are kind of advanced, okay, so that our students they use Python, they use KNIME, okay, to do all this kind of prediction model. Okay, so my student they do a quite good example. So the things that we evaluate more is not actually the model, the way he prepared the data, the way he analyzed which features that that really affecting the change of the concrete strength, for example. Okay, because you see the training of the model is very small portion. The preparation of the data is quite big. Okay, and that data we capture from literature review. Okay, from literature review. So you see, if the data is from literature review, wow, it's very noisy lah. Okay, it's not clean. Okay, I can say it's not clean. Okay, in some literature review they don't have that material. In some literature review they have another material which is not available in most of others like papers. Okay, all right. So in classification model, okay, what we predict is the response values that containing a class. Okay, so means that that variable is a categorical variable or nominal variable. Okay, in some reference, some books, they use the term nominal. Okay, so some books, they use categorical. So they are the same. So the value in categorical variable, we call them as a class. Okay, for example, purchase status. Okay, purchase status, buy or not buy. So purchase status is the categorical variable. Okay, and the value in that purchase status variable is either buy or not buy. So there are two classes there, buy or not buy. So buy and not buy are the classes. Okay, sometimes we call this as a binary class because we have either 1 or 0, buy or not buy. Okay, stay or churn. Ada dua sahaja kemungkinan dia. Okay, so sometimes they are multiple class. Okay, this is what we call multi-class problem. Okay, but if we go into multi-class problem, so dia lebih sophisticated and we have to do a lot of experiment, okay, numerical experiment to define the parameters. Itu baru kita panggil parameters. I forget yesterday. Ada satu soalan tentang parameters tu. Okay, later we will take a look into some of the parameters that we can optimize. Okay, so the goal of classification, okay, is to get the classifier. Classifier is what we call the classifier is the classification model that we're gonna use for the prediction. Okay, we name as a classifier. Okay, all right. So you see here, this is the two things that you have to differentiate between regression and classification. Okay, so regression, you predict continuous numerical output. So in classification, you will predict categorical output. Okay, sometimes you will find that the categorical, the classification problem, the value there is a number, 1, 2, 3, 4, 5, for example. But that is not a number that must converted into a class. Otherwise, when you do the prediction, it will try to predict as a continuous numerical output, not as a class. So you have to remember, classification is about predicting the class. Okay, if you have 1, 2, 3, 4, 5, so means that 1, 2, 3, 4, 5 is a class in classification problem. Okay, if the things that you want to predict is continuous value, so that is a regression problem. Okay, so we have to differentiate it. We have to understand it. Okay, all right. So these are some examples of credit scoring. Okay, I already mentioned it earlier. Okay, so these are the lists. I will show you two classifications: logistic regression and decision tree. Okay, the next, if you want to apply, okay, you already have in my ebook. So there is a lot of theoretical information there. Okay, how to choose the right parameters. Okay, how to what's this value, Gini value, if you deal with the decision tree. So everything already have in books. But of course, I will demonstrate more of the things we will discuss on this. But later, I will demonstrate how to use, for example, decision tree. Okay. All right. So let's take a look into the first algorithm that we are going to do. Okay. So logistic regression. Even though the name regression here doesn't mean that we have to predict the continuous value. Okay, the term regression appear here because it consider, okay, this logistic regression algorithm is derived based on linear regression. Okay, so in logistic regression, actually what we predict is the probability value of event to occur. So we have to define the success event. For example, 1 is success. So I will predict how many chances, what is the probability of event 1 to happen. If the probability is greater than 0.5, sorry, I use 0 here. Okay. So the success event is 0. For example, the success event is 0. So what will be the regression model, the logistic regression model here will predict, okay, the success event 0 to happen. Okay, so if it is greater than 0.5, this is the threshold, or equal to 0.5. So yes, event 0 will happen. Okay, class 0 will be the result. But if let's say the event or the class 0 is predicted to happen at probability less than 0.5, so means that another class, which is class 1, will be the output. Okay, so this is the result of this logistic regression. Okay, so in logistic regression, they presume all the input features are linearly correlated to the output features. Okay, this is the assumption. Okay, because we use this. Okay, output boleh more than 2 classes. Cannot. Output only can have 1 classes. Okay, so far dia tak ada based on 2. Okay, tak ada lagi saya tengok. Okay, mungkin unless you have a different set of category. Okay, contoh when I play football, what is the best 2 position that I can define this footballer? The first priority adalah striker, for example, and then another one apa dia punya. So you have to have 2 dua column to be used as the output. Tapi if you have only this one, for example, the status, dua-dua dekat satu column, so you have only 1. Okay, unless if you have 2 column. Pertama adalah position 1, second adalah position 2. Okay, so position 1 maybe the output will 0, position 2 the output will be 1. So you can have that. Okay, so in this case baru dia. Tapi kalau dalam satu kolom, okay, output dia kena 1 saja, tak boleh isi 2. Okay, alright. Okay, okay, so these are the differences lah. Okay, so output numeric, okay, categorical, class. Kalau untuk logistic, this is logistic. Okay, alright. So the way we measure ni dia lain sikit. Okay, kalau yang sebelum ni in regression problem we use R squared and adjusted R squared. But in logistic regression, we will measure in classification problem, not only logistic. Okay, in classification problem, we are going to evaluate it based on 3 indicators here: accuracy, precision, and also a recall. 3. Okay, so this will be summarized using a confusion matrix. Okay, so the performance ini yang saya cakap tadi, confusion matrix. Okay, so in confusion matrix, it will try to summarize, okay, the number of predicted, that correctly predicted, okay, how much of them are correctly are actually yes, for example. Contoh, you see, this is confusion matrix. This is summary of this from the model lah. Okay, for example, okay, after you do the performance test, okay, so you will found that the value that you predicted as yes, okay, so in actual they are yes are 69. So this is the correct value that we predicted as a yes, correct number of predicted yes. Okay, in other case I can say this is true positive TN, a true positive TP, by assuming that yes is a positive classes. So if yes is positive classes, no is negative classes. Okay, if you have more than 3 classes here, so you will have more sophisticated table. You have more column je. Okay, more column saja. The confusion method measure the accuracy of the model. Yes, it confusion matrix actually to summarize, okay, the findings, not to measure. Okay, because the accuracy is by computation. Ketiga-tiga ni is through a computation. The precision, the recall, and also the accuracy. They have to be calculated. Baru betul. Okay, and by the confusion method is to summarize the findings of your model. Okay, and also later on you will use this data to compute lah. So something like that. Okay, all right. Okay, so you see here when the total number of prediction that predicted as no, but actually they are yes, so 5. So this I can say as a misclassification classes for no. Okay, so this is misclassification for class yes. All right, okay. So I made another new table. Oh, correct. Sorry. One more thing. Okay, this is for true negative. Okay, you see the predicted no, the number of predicted as a no, 90 of them are actually no. Okay, so based on this summary, I can compute class, position, and also accuracy. Okay, let's talk about the accuracy. Okay, so accuracy means the overall, how many of classes that we can identify as a correctly. I mean, I can predict correctly. The model can predict correctly. So true positive plus true negative, correct? So predicted yes 69 plus 90 and must be divided with the total observation here. Okay, so these are the total observation. 69 plus 5 plus 4 plus 90 is the total observation. So to get the accuracy, so you must do 69 plus 90 divided by total observation. You will get the accuracy. Okay, you always can transform it into percentage by time 100. Okay, so 95% accuracy, something like that. Okay, so how about the recall? Okay, the recall indicate, okay, the number of selected classes that been successfully predicted, I mean, have been correctly predicted for that classes. Contoh, in the group of actual yes, ini adalah yes punya group. So the total actual yes adalah 69 plus 5, right? The total actual yes. So how many of them been predicted as yes? So 69 divided by 69 divided by 69 divided by 69 plus 5, correct? So that will answer that kind of question. Okay, if I talk about the precision, okay, what is the chances that if you are predicted as yes, you will get yes? Okay, so in this case, we will take a look into the number of predicted as yes. how many of them are actually yes? So in this case, 69 divided by the total number of 69 plus 4 will give you the class position for class yes. Okay, sama juga dengan no ni lah, the same thing. Right, so if you have a high accuracy, 90%, doesn't mean that your model is good. Okay, that's why you have to check the another two values here. Okay, so these are the important indicator. Okay, to shows the performance of your model. Ada 3 parameters, ada 3 matrix ni yang kita akan gunakan. Okay, alright. So yang result, if you already get familiar, saya pun dulu awal-awal mula dulu pun nama pun dah confusion matrix. Okay, so kita pun boleh confuse lah. Okay, tapi actually the name of confusion ni sebab it will try to find which one macam mana model ni confuse. Itu sebenarnya. Tapi I'm representing as it also make me confuse. Ya? Okay, tapi lama-lama kita dah faham dia punya try. Dah boleh faham lah. Okay, alright. Okay, so the next task kita tak buat yang ni, kita buat yang tersusah dia. Okay, I will use the most difficult problem. Okay, so our next task letter, okay, we will build a machine learning model using a logistic regression to predict the result of exited status of customer in bank A. Okay, we are going to use bankchurn.csv. Okay, kita akan gunakan dataset bankchurn.csv nanti. Okay, alright, so okay, so I think we can take 5, okay, take 10 lah ya. Before that, can we have a group photo? Nanti terlupa. Bila kita dah discuss lama-lama nanti malam, can we have a group photo and make sure we open our, apa namanya? Kita buka kita punya kamera, boleh tak? Okay, nanti takut terlupa. Ya, always do that. Okay, since this is our last class today. Okay, since this is our last class today, so I hope we can open our camera. Okay, okay. Oh, memang saya pernah memang familiar lah faces. Okay, right. Okay, okay. Apa lagi? Kita tunggu sekejap kawan-kawan lain. Okay, so there is a group from IBIC here. Okay, Dr. Akmal ya. Ada juga group dari mana dari Zaino, macam dekat office je. LSDN, Zaino LSDN, right?
Ya, doktor, dekat rumah.
Oh, dekat rumah. Oh, ingat dekat office. Okay, so we wait others. Okay. Alright, you also can take the pictures and I will take. Okay, kita tunggu sekejap. Catherine, ya, Catherine. Yeah. Okay, this is actually the first batch lah for our group. Okay, first batch for these courses. Okay, 1, 2, 3. Okay, allow me one more time. Okay, 1, 2, 3. Okay, alright. Okay, so okay tak kita rehat 5 minit. Okay, tapi siapa yang nak buka kamera sampai habis pun bagus juga, baru nampak macam ada orang. Okay, alright. Okay, so we take 10 minutes. So I see you 9:30. 9:30, and then get ready with a new data set of bankchurn nanti. Okay, alright. So see you later. Okay. Okay, so there is a question there. Okay, Helmi, Codless or deep learning. Okay, nanti contact saya personally. Okay, you can later I will tell you the price for that one. Okay. Satu lagi actually sudah habis tadi. Okay, so bila saya post saja dah habis. Okay, yang dua memang dah di book by ada yang join saya sini sebelum tu. Okay, yang tiga terus habis. Tapi saya akan order a few copies lah. Okay, a few copies lagi, and hopefully by this end of this month or next month, early next month dia sampai lah. Okay, boleh pre-order tapi bayar dia nantilah lepas benda tu sampai. Okay, and then baru bayar ya. Nanti communicate to me personally lah on that. Okay, if you really interested, I can put you in the waiting list. So bila sampai baru bayar. Saya tak minta dululah. Saya tak nak tu. Okay. So untuk yang group ada yang order, so kita tengah proses untuk courierkan sebab nanti kita preparekan receipt sekali. So tomorrow allow me this maybe tomorrow or these 2 days to prepare the, sebab saya nak bagi proper receipt to all the yang sudah ikut this program, so you have to key in few information lah. Maybe you guys want to claim for your organization, so you can use that receipt lah. Okay. Anything I will mention in the email. Okay, anything we mention in the email. Okay. So for those who are interested with the book, so personally contact me. So I will put your in waiting list and I will tell you the price there. Okay. All right. So okay, it's quite good lah. Saya pun quite impressed. Quite the things is I try. Okay. Cuma ada satu je yang dia tak mungkin detail bagi tahu macam mana nak set up your punya environment. Okay. So that environment is a little bit tricky. Okay. Unless you already familiar. Saya rasa ada yang pernah tahu. I guess dia tahulah that environment tu. So anyway, I try to help. Okay. Mungkin dalam minggu depan I will finish that video lah. Okay, so you guys can take a look how to set up. Itu pun saya cari-cari ya. Dia tak ada. Saya try to read the guidelines. Okay, dia ada bagi tahu, cuma kind of confusing. So saya cuba at the end jadi juga dia. Okay, baru dia boleh communicate with my Keras and TensorFlow. Okay, so that book is quite interesting lah. The content is okay. They use a simple content, but of course the way they make a workflow. Okay. And what I see is I use Python before, okay, untuk saya do the deep learning, okay, even image processing. Tapi nampak yang ni lebih senang, biasa macam ni lah. Macam yang kita buat ni, guna Python, wah, kalau yang dah biasa senang lah, okay. But for those who very new, okay, it's kind of challenging, right? I think siapa yang baru machine learning sini? I guess
saya Greeny. Saya first time ni.
Yeah.
Yep.
What do you think? What do you think after is it first time?
For me, if it's like this, doctor, I can do it because statistical analysis saya dah biasa.
Okay.
Tapi lah biasanya kita guna itu yang saya tanya SPSS ataupun buat run ke Excel ke. But if it's like this, it's a lot easier.
Yeah.
And the way you explain, it makes, because I'm a very visual learner.
Okay.
It gives me a new perspective of understanding stats and the data. So for me, I'm really enjoying it.
Okay, all right, good. Thanks. Okay, thanks.
Doctor, so from your experience, Doctor dah memang biasa guna Python juga. So in terms of accuracy, is both the same? Would you say that KNIME and Python?
Yeah, same. Actually same. Okay, dia sama je. As long as feature yang setting yang kita pakai tu, contoh dia punya parameters yang kita adjust tu, dia sama, so supposed to be same lah. Kalau beza sikit pun dia sangat sikit je, dia tak banyak. Tapi kalau kita run macam yang net classification model, memang nampak dia sama. But as long as the parameters, contoh seeds dia kita set sama, supposed to be same.
Right, thank you.
Yeah, alright. So Catherine, learning for me Python is yes, correct. Okay, correct, Catherine. So but if I'm not sure if you learn from me, okay, the thing will be more easier. Okay, so I'm not sure for those who joined me before. Okay, join me before. Maybe siapa Kevin pernah join, Cindy, maybe. Okay, what do you think about the Python? Maybe you can share that. Akmal, okay, our website, yeah, please. Okay, PKP, ya betul. Kita Akmal dekat Kelantan kita nak pergi ni Kelantan ni, and Dr. Elvin want to.
Ya, Kelantan.
Kelantan
boleh,
kan?
boleh. Ya, boleh.
Boleh ya?
Sebelah airport je. Sebelah airport.
Kan sambil cuti-cuti sikit, betul tak?
Okay.
Pas boleh ni lah. Dengan katanya pengumuman yang dah dapat 2 injection macam hari ni atau esok saya pun lupa. Tengok news lah, dia kata macam hari ni besok. Okay. So actually IBIG is a big data punya research group. Correct me if I'm wrong. Okay, Akmal. Big data research group from UMK. Okay, and they are very committed lah on developing and also provide training dan juga consulting lah for the big data. Correct Akmal? Okay. Alright, so lagi sini. Extra notes Python on statistics. Ya, kalau ada saya boleh share. Okay, through email. Tapi setakat ni apa cara? Biasa saya guna slide saya saja. Okay. But if I have extra notes, of course I will communicate lah. Okay, I will send. Okay. Right. Okay. Alright. Okay, Helmi dia ada tanya, can KNIME be used for satellite image classification? Okay, so it's depend. Okay, I think if we got the anything, kalau kalau data tu dia dalam bentuk JPEG, is it JPEG, Helmi? Helmi, JPEG? Is it JPEG? Dia pun mau JPEG ataupun apa? BSQ. Oh, that one I'm not familiar. Sorry to ni, tapi TIFF I guess boleh. We can use the file reader. Okay, some of the images we can use file reader to read that. Okay, sama juga dengan teks. Okay, tapi saya belum pernah cuba. Okay, maybe in the future we can get a try into this. Okay, Helmi, boleh tak? In the future we are going to explore on this. Okay, it's quite new lah. Okay, biasa saya guna itulah JPEG ataupun PNG, shouldn't be a problem with the image reader, image reader. Okay, alright. Okay, Catherine. Okay, sure. Okay, apa lagi ya? Can be ni statistics. Okay, alright. KNIME ada analysis special. Macam ada, I already search on that before. Saya macam ada tengok, ada dia punya group tau, dia share dekat, if you subscribe to their website, sometimes they always, apa nama ni, tapi saya macam pernah dengar spek yang guna KNIME. Okay, sekejap, cuba saya search sekejap. Okay, KNIME, if I not mistake, they have Okay, so you see here in the forum, if you can take a look here, okay, tapi most of these, the ETL process dia kita kena define sendiri. Macam yang Syabnam ada tanya saya tentang Monte Carlo tu, we have to define, macam programming juga, some of the analysis dia tak dalam bentuk nodes tu, dia belum ada tu. So we have to define the workflow itself by ourselves. Okay, so ini benda yang berlaku lah. Okay, so maybe I'm gonna take a look into that kind of question. Maybe I'm gonna take a few examples in the future. Kita boleh buat sesi free webinar lah for me to share on this. Okay, I can get that. Okay, right. Okay, so anything else? Okay, so nanti kita sembang lagi. So we continue with our lesson. Okay, alright. Okay, lebih itulah term kasih. Okay, alright, okay, terima kasih WB. Okay, alright, so let's continue on kita punya task. Okay, kita punya task. So kita tak buat feature extraction here because it's going to take about 1.5 hours. Okay, maybe more. So I presume that all these can be used as inputs. Okay, the things that matter right now is to understand the workflow when we want to train the algorithm, because later on there will be a new feature that we have to understand. Okay, tapi bagi yang pernah ikut kelas machine learning, dia dah tahu, okay, what I want to tell. Okay, but in this case, I want to show to you, okay, the exact, okay, what we going to happen, the things that might be different compared to the the regression that we learned before. Okay, so our task is to build the machine learning model using logistic regression algorithm to predict the exited status. Okay, existed status nih. Okay, so ini adalah dia punya data point, and this is a single observation of a single customer. Maksudnya individual customer. Okay, credit score dia macam ni, France, she is from France. Okay, gender is female. Okay, and then churn. Maksudnya churn ni adalah dia unsubscribe lah. Okay, after 3 years, for example. Okay, but some maybe stay. Okay, so we want to build a model to predict their activity. Okay, whether that if let's say in the future I have the customer in this data set, will that customer will churn or stay? Okay, so the exited status is in categorical value, categorical variable or nominal variable, benda yang sama, and they have two classes, churn or stay. Okay, and then the other variable we have ini adalah more like apa kita panggil continuous number. Okay, age, tenure, okay, balance, number of product, okay, berapa number of product dia subscribe to that bank. Okay, contoh credit card, okay, loan, okay, ada tak dia credit card 1, 0, okay, so is it an active member? Okay, maybe selalu tak dia active, seminggu at least 2-3 kali tak dia subscribe log in to the bank, and what is the estimated salary. So these are all the input features lah. Okay, so we are going to assume that all these will be going to be used as an input value. Okay, okay, so import ni dulu. Okay, kita import dia, jom kita import, make sure dia dalam folder machine learning, jangan import dia dari folder lain, nanti data dia lain sikit nanti. Okay, wait, CSV, okay, CSV, salah, CSV reader, sorry. Okay, CSV reader. Okay, sebab saya tengok color dia macam lain tadi ya. CSV reader. Okay, so browse, look for the machine learning punya ni, and then look for the bank churn. Okay, look for the bank churn, then click open. Okay, click open. Okay, so dekat sini ada few missing values. So you see here, there is a missing value. So we do some treatment lah. Nanti kita buat sedikit treatment lah okay, into these missing values. Okay, and then has row ID. Okay, so kita jadikan dia sebagai row ID because I don't want this to be used as the apa nama nanti. Saya tak nak dia apa ni. We don't want this column to be used as an input. Okay, so dia juga ada, kita ada juga data set yang lain. So registered date ya. So saya tak nak registered date tu. Mungkin tak payah ya. So kita unchoose that one. Go to transformation. Okay, and then untick that registered date. Okay, I believe we get the same data set here. Okay, just let me check the one that I used before. Sama tak? Lain tak? Saya rasa lain sikit. I think this data is, let me check first. Let me check. I think I use betul lah. Blah, blah, blah. Okay, betul. Okay, betul. Okay, that's correct. So what I want to do, okay, benda yang saya beritahu tadi, okay, so we go to a CSV reader. Saya belum import. Okay, go to find that file once more time. Ni. Okay, go to transformation and then untick dua ni. Ini tak payah. Okay, no need to use this. Okay, because I want to work with my machine learning model. Okay, so registered date tak payah and customer ID ni tak payah. Okay, we want to focus on the machine learning parts. Okay, all right. So you see, this is the form of the data set that we have. Dan kita ada dua missing value kat sini. Okay, there is two missing values there. So we're going to treat that missing values. Okay, we are going to treat that missing values. Tapi kenapa data yang saya ada sini tak ada missing value? Okay, tak apalah, kita treat that missing value. Okay, so use missing values. Column filter. Okay, missing value here. Okay, so tadi ada missing values tu, we have to import, and then how can I check that missing values is using a data explorer. Cuba search for data explorer. Okay, search for data explorer. Drag it here. Okay, then go here and then look for that. Okay. Okay, nothing much to be configured here. So look for the missing value. Which variable that have missing value? Okay, so estimated salary, one missing values. What else? Okay, so if we go to nominal data here, okay, exited, we have one missing value here. Okay, so you see, how do I treat estimated salary? Because salary is more like this. Okay, so what I can do, I can just use the mean value or median. Okay, contoh saya gunakan median pun boleh lah. So in this case, the mean value is here, or I use the mean value. Okay, saya gunakan mean value untuk replace that missing values. Okay, so we go here and then connect it. Okay, double click this missing value. Ini kita tak payah buat apa. Then go to column setting punya tab. And then estimated salary. Double click on it. And then do mean value. Okay, I will replace that missing value with the mean value. Okay. Another one that we have missing value is nominal. Okay, so nominal we have exited. Okay, yang ada missing value. So in this case, which one? I want to use the most frequent value. Okay, the possibility of that missing value is the one that most frequent. Itu. You can use any others. Okay, ini terpulang. Okay, depend on your judgment. Whether you want to fit it as a stay, okay, or churn, you want to just directly, ataupun you nak our system, okay, compute it to us. Most frequent value, for example. Okay, so use a most frequent and then apply. Click OK. Run it. And I believe if I drag this here, okay, so now we don't have any missing values. We look for it. Okay, ada tak missing value? Okay, dah tak ada, selesai. Nominal pun tak ada, Okay, tak ada missing value. Okay, settle. Okay. Alright, so that is if our data has a problem. So itu simple problem lah. Okay, itu adalah most simplest problem. The next thing that I want to visualize, okay, problem couldn't catch. Okay, sure. Alright, Catherine. So yeah, later I contact you. I have your number, okay, or maybe through the staff that communicated with you earlier. Anything, any updates, I will communicate with you later, yeah? Okay, can I? Okay, but please watch the video and then follow the example so that you will get the fully experience of using KNIME in the analytics project. Okay, Catherine, thank you very much. Okay, all right, okay, all right. Okay, so let's me continue. Okay, So mana kita tadi? Missing value. Oh, another one. I want to. Okay, boleh. Missing value sekejap ya. So missing value here ada dua missing value tadi. Okay, so estimated salary and exited, correct? So you double click on it. So you see estimated salary. Okay, so how can I replace the estimated salary? So from here, you see the estimated salary punya graph. Okay, I can choose actually. So kalau kita tengok dia lebih kurang taburan dia sama je for every range of this. Okay, the count of the value for every range of the salary. So my justification, I can use mean. So that mean we're presenting the mean value so that the individual yang ada missing value tadi ini dia punya salary. So by using a mean, or if you have the data of that missing value, so you also can key in that data. Okay, so you can key in the data. Mana ada tadi? Yep, ini boleh padam. Okay, ini pun boleh padam. So okay, if you want to key in the data, so you can go to contoh, you can choose fixed value, or you can do nothing, biasa tak adalah nanti error. So I can use even maximum value. Okay, but I want to use mean. Then use median. Okay, if you also can use previous next value to that particular row, tak ada masalah pun boleh. Cuma if you see the asterisk here, it will create a problem if you want to save it in PMML format. Okay, so that's the things happen. Kalau exited nih, because exited is a categorical, not numerical, so we cannot compute the mean. Kita tak boleh compute dia punya aggregation tu based on mean, based on maximum, based on minimum value. Tapi saya boleh gunakan most frequent value, next value, or even remove that particular row. Okay, so in this case, I want to use a most frequent value. Okay, and then click apply. So supposed to be lepas tu dia tak ada missing values lah. Okay, boleh ya, Helmi? Okay ya. So if you want to do the aggregation value to be used to do the replacement of that value, kita panggil that sebagai imputers. IMPUTER. Okay, imputers. Okay, so that, how do you justify that? Is it correct? Okay, dia tak ada solid answer into that. Okay, it's based on your perception. Okay, based on perception. And most important thing, number of missing value tu kalau boleh jangan banyak lah. So if you just replace or remove one of it, doesn't matter. Okay, so the next thing is I want to understand what.
Sorry.
Yes.
Saya punya CSV data tu ada error. It says I duplicate on row.
Yes, correct. Sebab tu saya nak kita ni.
Okay.
Transformation ni.
Gotcha.
I don't want to deal with the apa nama ni? Customer ID ni.
Okay.
So actually there is a duplicated values. I believe ini yang row 5 dan row 6 ni. Okay, but if you want to do that treatment also can, macam mana apa yang kita nak buat maybe okay, because I don't want to include this in our data set, so tak apalah.
Okay.
But I want to treat that. I think we have to treat that. Okay, so just click on it. Just click on it, doesn't matter, that's not a problem. And then click apply, and then click OK. Okay, just click on it. Is it okay? Right, and then run it. Of course, tak ada error sebab saya tak jadikan dia. Okay, if you don't want that to be error, so you don't use has row ID dekat sini. Okay, yang Syabnam tadi saya rasa arrow dia dekat sini. So we don't want that.
Okay, alright.
So click OK. And then we treat that duplicated value. So type duplicates. Okay, duplicate row filter. Okay, and then connect this one. Yeah. So which one do we want? Yang kita tak nak duplicate. Kita tak nak duplicate customer ID. Okay, so I have to use this. Okay, so what I can do, if there is a duplicated, so I have to remove it. Okay, so dia akan remove duplicate row. Saya
Okay.
tak nak keep dia. So remove duplicated rows. Okay, so and then we run it. Okay, how to know there is no duplicated row anymore? So you go here. Okay, you go here and then click open views. Kita boleh tengok dekat ya nominal data. Okay, and then dia akan shows. Okay, in this case, so you see sebab dia adalah unique kan. Okay, so dia tak ada bentuk macam ni. Okay, and another one I can use statistic nodes. Okay, statistics nodes. Okay, search for statistics. Okay, yang ini bagus untuk kita tengok duplicated values. So when I execute this, okay, execute, tapi kita nak view dia dalam sekejap. Oh, ini saya tahu kenapa. Okay, go here and then letakkan ini dalam bentuk maybe 20,000. Okay, ini adalah possible values in column. Sometimes we have a lot of unique value. Okay, so we just put the total number of rows that we have greater than the number of rows that we have. So and then click apply. Okay, so it's supposed to be there will be not any apa dia tak ada bagi kind of not error. It's just a warning. Just a warning. Okay. So you go here and then search for occurrence table. Okay. So from here we know the number of dia akan biasa kalau ini duplicated dia akan muncul yang paling atas. So in this case all these are unique. Maksudnya customer ID with 100 okay muncul sekali. Okay, kalau dia like for example France, France ada 5,014. So dia akan muncul paling atas. So in this case maksudnya tak ada duplicated value based on ID. Okay, so we already treat that duplicated error. So now the data already get ready to be used for the next stage. Okay. All right. So sekarang ni, what do you think we have to do? So this is our data set. Okay, and I'm not going to use this. So we can drop this column. So macam mana nak drop column tu? Gunakan column filter. Okay, ataupun we can do it later. Okay, we can do it later. So what do you think the possible things that we can do right now? Okay, so sekarang ni kita buat sedikit apa nama ni univariate analysis into the output features. Okay, so univariate is to understand a selected features individually. The most important things adalah kita nak tahu output. Okay, the possible the response variables. So I want to see how many people, how many observation in the data set are churn or stay. Okay, you can use a group by, tak ada masalah. But what I want to use is just pie chart je. Okay, pie chart. Okay, gunakan pie chart. Okay, so you perform a little bit univariate analysis into that particular output ataupun response column. Okay, so pie chart what we want to do is exited. Okay, correct. And saya nak tengok dia punya occurrence count. Okay, and then click apply. Okay. So if you see here, okay, they are more than 75%. Yeah, okay, 75%. Okay, more than about 80%. Okay, the observation are stay, and only 20% the observation are churn. Okay, this is what we call as an imbalanced data set. Okay, and the problem with the imbalanced data set, it will affect the model later on. So the model will confuse. The model will be, there will be a bias into the algorithm to learn from this model. Okay, so before this, when we do the regression, okay, dia tak ada imbalance like this. The problem is not related with imbalance. Okay, so in this case, the things, okay, because we want to, the model learn based on response, so dia akan lebih banyak belajar dekat state instead of churn. Similar things happen when we do a fraud analysis. Fraud analysis lagi lah, mungkin 5% je, because not much fraud problem happen. And also in the bank cases like this, okay, of course stay lagi banyak lah. Kalau jumlah stay dan churn 50-50, itu maksudnya not company tu perform tak bagus lah. Okay, kalau in this case, okay, the total churn rate 20% je, besar juga. Tapi kalau boleh kita nak minimizekan number of churn. Okay, so that's why they will create an imbalanced data set later. Okay, so di mana dia akan kacau nanti kita akan tengok. Okay, now what we can do is, okay, next adalah saya nak, you see, this is all we call as a categorical variables, right? So I want to use categorical variable as an input, so I must change that into a numerical dummy variables. Okay, so numerical dummy variable. So in this case, we change them into a numerical dummy variable menggunakan one to many. Okay, gunakan one to many. Okay, so drag this one to many. Okay, and then drag it here. Okay, all right. So customer ID tak payah. Exited pun jangan convert. Sebab kita tak nak exited dalam bentuk nombor. Exited must be in the class. Customer ID tak perlu, memang tak perlu. Okay, sebab dia is not part of the inputs. Okay, customer ID is not part of the inputs later. Okay, and then click apply. Right click and right click and execute. Okay. Okay, so right now we will see that, okay, we have France, Spain, and Germany. This is the dummy variables that been created. Okay, so you see here, if this is France, so France will be 1, Spain and Germany will be 0. Okay, and also female and male, same. All right, so if there is female, so female will be 1, male will be 0. Okay, so this is what we call as transforming the data into from the categorical into a dummy variable. Okay, so the next thing is to select which column. Okay, sekarang ni mana satu yang saya nak go to the next stage from this data. Okay, which one that I want to go to the next stage, that of my data pre-processing. Okay, of feature engineering punya activity. Okay, so of course I don't want to include, pertama saya tak nak include row ID tadi. Okay, I don't want to include that row ID. Okay, and second, I don't want to include geography because this is categorical. I don't want to include gender, and I have to remove one of France, Spain, and Germany. I have to remove one of it to minimize the multicollinearity effect, dan juga kita panggil dummy trap, sama juga dengan this one, either female or male. Okay, so my decision to drop one of it is based on the ini dekat sini occurrence table here. So I will remove the one with less values. For example, in this case is Spain. Okay, so kalau yang dekat gender, I will remove female because count dia paling kurang compared to male. Okay, so I can remove one of them. Right, so how to do that? Okay, so we remove that. We use a column filter. Search for column filter and then drag it. Okay, drag it. Okay, double click on it. Okay, so I don't want a customer ID, okay, as I mentioned earlier. I don't want a geography. I don't want a gender. And then I have to remove female, and then I have to remove Spain. Okay, because Spain, we have to remove one of the dummy variable to avoid multicollinearity effect, and also to avoid dummy trap. Okay, and then click apply. Make sure the exited ada. Kalau tak ada exited, nak predict apa kan? Okay, exited ada. Click OK, right click and execute. Okay, so now the data is ready to the next processing. Okay, to the next process. Okay, all right. So the next, any guess what we have to do? Apa yang kita kena buat ni? From this data set, what do you think we have to do? Any guess here? Ada cadangan tak? Kita kena buat apa? Yes, normalize. Okay, okay, and or any else? Normalize. Okay. So the reason is because we don't have, because the data set is not consistent. Okay, they are not the same range. Okay, so we have to normalize it. Dekat sini saya gunakan normalize, menggunakan min max juga. Okay, so drag the normalizer here. Okay, okay, drag the normalizer here. Okay, and then connect it, and then normalize only for the, okay, all the kita panggil sebagai numerical value, tapi dia automatically pilih lah, maksudnya exited will be not included. Okay, in regression problem kita tak include dia punya numerical values. Okay, in regression problem. Okay, so in classification problem, automatically it will be not included. Okay, because it's not a numeric value. Okay, so just click apply and use a min max normalization. Right click and execute. Okay, so now when we check the normalized table, so we will see that all these value exited, okay, they are already been normalized. Okay, so next, after we do the normalization, we have to do the partitioning before we can train the data set. Okay, train the algorithm, sorry. Okay, so we partition the data set and drag into it, and here we have some problem. Okay, so this is the most the things that make it differ compared to the regression before. Okay, so if you see here, okay, if I took it randomly, for example, I took it randomly, okay, okay, this row is go to the trend set and this row go to the test set. Okay, so what will happen due to the imbalanced data set, okay, due to this imbalance problem, maybe all of the, what we call, all of the churn punya data, okay, the observation that containing churn as their value of response, okay, all will be put into a trend set. Tak ada pun yang pergi test set. Okay, this can be happen. Okay, this can be happen due to the imbalanced data set. Ataupun terlalu banyak data set yang akan pergi ke trend set until very less, okay, go to the test set for this one, for the churn status. Ataupun very less go to the trend means that your model will have a bias to predict state. And what I can conclude here, the model later on you will see that the model is better to perform stay compared to the churn due to the number of the data. That's why at the beginning we learned that the more data that we have, the better the model learn from it. Sama juga dengan in this case. Okay, in this case, the model will better learn for the stay classes compared to the churn classes. Okay, so in order to minimize this bias, okay, so we have to apply a new strategy for the partitioning. Means that if I want to partition this data set into 80-20, for example, okay, betul tak 80-20, okay, 80-20%. So means that I will okay, I use 20 dekat example, okay, I use 20 here. Cuba tengok 80 guys, 7963 times 0.7, 0.8. Okay, betul. Okay. Okay, so in this case, okay, so you will see that the trend set, for example, the trend set I use 80%. So instead of I took it randomly, I use a stratified sampling. Means that 80% I will take from stay, and then 80% I will take from churn. Okay, so by using a stratified sampling, I can maintain the proportion of this class. Okay, so if you compute 6370 plus 1630, it also 80% from the overall data set. Maybe 8,000. Okay, 8,000. Yeah? Okay, they will give you 8,000. The rest will be another 30%, 20%. Okay, stay 1593. Okay, so this one is 20% from this stay group, and then this one is 20% from this group. So ini kita panggil sebagai stratified sampling. Okay, so we cannot eliminate the normalized. Okay, and we cannot dia akan ada juga in this case. X cross fold. Okay, so X cross fold dia lain sikit. Okay, dia adalah by group. Okay, all the data, all the observation boleh digunakan sebagai trend set, dan juga nanti dekat group lain dia boleh digunakan sebagai test set. So X is the group, okay, as the group of this the group of sampling. Okay, mula-mula kita mungkin sampel yang pertama, let's say if I divide this into 10 group, maksudnya satu sampel ada 100 data set. Okay, and this 100 data set I will take it randomly because I don't care, because at the end of the day all the data set will be used as either trend set or test set. Kedua-duanya digunakan. Itu yang berlaku dekat cross fold, X fold. X maksudnya we have berapa folder, ya, berapa groups of this fold. Okay, but you see even the cross fold pun tak boleh solve this kind of problem. I already test it. Okay, so let's take a look into the next. So important to understand the data. Yes, that's correct. Okay, so it's important. So that's why we always have to do the data exploration before we just dump it into a machine learning. Okay, so we have to understand that. Can we use smooth? Yes, can. Okay, tapi saya pernah buat juga smooth. So smooth algorithm will amplify this one. They try to predict a group of number of these. Okay, at the end apa yang saya dapat pun still it will bias toward this group. Okay, tapi mungkin dia reduce sikit that bias. Okay, ada juga. We can use smooth untuk this case. Okay, the smooth, okay, it amplify the data set. Okay, you can always apply that. Right? Okay, yeah, cool. Okay. All right. So I will teach you one more later. Macam mana saya nak choose parameter mana yang saya nak amplify kan. Okay, ada satu teknik. Okay, so class today kita tak, saya rasa tak sempat habis pukul 11 ya. So kita speed sikit. So we have to choose. Okay, kita kena choose. I choose 80% here, and stratified sampling based on exited. Random seed I set as 0. Okay, all right. Okay, so right click and execute. Okay, and on the petition 80%, second will be 20%. Okay, so the next thing is I want to train the algorithm. Okay, all right. So train the algorithm. So I use a logistic. So search for logistic. So go to analytics, go to mining, search for logistic. Ada tak logistic? Ini. Okay, so search for the logistic and drag both of it. Okay, dragkan kedua-duanya. Okay, so the first will go to train the model, and then the model will be carried into the predictor, and then the second will be go to the predictor lah, the second partition. Okay, so here semalam ada soalan mengenai apa nama ni parameters ya. So dekat sini baru kita panggil parameters. So these are the parameters that you can examine or perform a kind of apa kita panggil kind of experiment. Okay, so contoh berapa number of epochs that I want, what is the number of epsilon. Okay, ini dalam buku saya ada cerita lah, the number of epoch is the number of repetition that we want to find the gradient descent for this data and for the iteration. Okay, so how to define that gradient descent to determine the optimal model, okay, of this logistic regression adalah either by stochastic average gradient ataupun iteratively weighted at least square. Okay, so biasa saya guna stochastic lah because there are a lot of point there. Maybe some of the inputs they are not linearly correlated with the output. So I better use a stochastic model. Okay, and then the reference category, I can use stay or churn, terpulang. Maybe I use stay. Okay, it will not affect more. Okay, so the next is to apply the model. Okay, katakanlah kita gunakan setting yang default. Okay, you can try the future and see which setting that is give you a better result. Okay, so logistic here I want to I want to have another column here. Okay, column prediction, column name is prediction exited, sama juga, and even I can append the probability. Okay, maksudnya ada probability of event to occur. Okay, so in this case I just want to see here. So this must be ticked because later on we will use that as a validation. Okay, so right click on this and execute. Okay, so when I right click, okay, so you can see here. Okay, so mana exited? Ini exited. So if we predicted as stay, actual dia adalah stay. So ini count as 1. Okay, so ini dah 2 dah. Maksudnya when we predict as stay, the actual stay ada berapa? So how to get this summary? So we use a confusion matrix. So to use the confusion matrix, so we have to use a scorer node. Okay, go to scoring here and then search for scorer. Okay, bukan numeric ya. Kalau regression numeric scorer. Now in this case we use a scorer node. Okay, use the scorer node. So drag this. Okay, and then the first column I can use just dekat sini to avoid the confusion letter. So here I use apa? Yep. Okay, I use exited. Okay, and then this is predicted. Okay, so click apply and then right click and execute an open view. It will give you the confusion matrix like this. Okay, I got 81.7%. I'm not sure you guys get what. Okay, mungkin sama atau tak. Okay, but doesn't biasa dia tak lari banyak lah. Saya rasa dia akan sama. Okay, so ini yang saya run semalam. Tengok dia lari sikit. Okay, this is due to the seeds that we define. But it's okay. I will describe this model based on the one that I already run before. Okay, let's say you get the same result as me. Okay, so you see here, this is my confusion matrix. Okay, this is my confusion matrix. And this is my accuracy statistic, which I can obtain by right click and then go to the bottom one. Okay, bottom data table. So it will give you the summary of your statistic for your model. Okay, so in this case, we try to describe that. Let's say we have this kind of data set. Okay, tak kisah. Okay, tak kisah macam mana. So what we can do here, okay, what we can interpret from here. Okay, so you see here the churn, this is the number of churn. Mula-mula dia predicted 1 to 4, so the number of actual churn berjaya dia predict is 1 to 4. So overall it gives us this accuracy. Is it good? Okay, so that's why you have to evaluate it based on classes. Okay, so ada dua metrics that we can use to evaluate this based on classes, which is recall and also position. Okay, so if you take a look into a position, dekat sini more important is position. Okay, so in position about 63%, okay, of the churn can be identified, can be, I mean, when you predict it's a churn, the actual churn are 63% sahaja. Okay, but if you predict, okay, as a stay, so we'll get about 82%. So nampak tak the imbalance of this data set? Okay, so my model is better to predict stay. Okay, if you see the recall, you see 97% of the stay. Okay, kalau kita tengok stay ni, nampak tak 87% berjaya dikelaskan. Okay, if I predict, if the actual, kalau kita tengok dekat sini, so ini yang kita berjaya grupkan sebagai stay. Okay, kalau churn hanya 20% saja. So banyak yang misclassification from here. Okay, so in this case, the model is not that accurate. The model, even it shows 81.4%, but doesn't mean that if, let's say, you've been predicted as a stay, you are actually stay. It's not like that. Okay, so there is only, you can determine that based on position. Okay, so this is due to the imbalance data set. Okay, due to the imbalance. Okay, all right. Okay, so cuba kita tengok another apa kita panggil, kita gunakan another we use another algorithm here, decision tree. Okay, as I mentioned to you, we also can use others algorithm. Ada banyak lagi algorithm kita boleh gunakan. Salah satu dia adalah decision tree, ya. Okay, so padam ni, padam. Okay, we remove the sophisticated thing. Okay, so saya nak gunakan decision tree pula. Okay, tarik ini sikit. So let's try look for the decision tree. Cuba tengok decision tree. Okay, this one. Okay, so dia ada dua, macam sama juga, decision tree learner node and decision tree predictor. Okay. All right, so we connect this to train the algorithm, and then we connect this to apply the model that have been trained. Okay, so here we can see a lot of parameters that we can adjust. Okay, make sure the class column is the output. Okay, in this case, dia dah identify lah. Okay, and then how do you want to measure the quality of the pruning? Okay, I guna Gini index here, guna gain ratio. So ini kita guna Gini index. So in my books, I already explained on this. So let's say we use all these parameters as suggested. Okay, katakanlah kita gunakan parameters as suggested. Okay, nanti saya akan tunjuk sedikit tentang optimization. Okay, so click apply, then click OK. So, and then this one, change number of column name. Prediction column name ini tak payah, ini memang dah default. Then click apply. Okay. Execute. Okay. So kenapa nak bentuk dia dalam decision tree? Okay, ini yang kita panggil decision tree. You can always check okay, what is the thing inside the tree here. So this one also been described in my notes lah. Okay, dekat sini, wah ini banyak nih. Okay, because it involve. Okay, kalau kita gunakan at the end, at the beginning age, and then how I split it based on age. So dia ada banyak nih yang dia consider on the splitting process. Okay, so but more important is kita nak tengok scorer lah. Okay, kita nak tengok scorer. Is it improvised the model? Okay. So kalau tengok accuracy 79, let's take a look into the one that I already rerun before. Okay. So dekat sini saya dapat, how can I get much better? 84. Before this, 81. This one 84. I guess, what did I do? What did I do to get much better? Oh, I know what I do. Okay, saya tahu apa yang saya buat. Okay, tak apa. Okay, so you see here, if you see the we see the accuracy statistics. Okay, cuba kita compare. Ya. Cuba kita compare dua ni. Okay, ini adalah decision tree. Ini adalah logistic regression. Okay, by right, if you see here, the total accuracy, ini turun sikit lah, decision tree. Cuba kita tengok the things that matter, which is the precision. Okay, kalau kita tengok precision, dia improvise stay, tapi dia tak improvise yang ni. Yang, sorry. Dia tak improvise position untuk churn. Tapi dia improvise recall untuk churn. Okay, so this might be a things that you have to consider. Which model is good? Which model do you think is critical for you to predict? Okay, contoh dalam situasi case of you've been infected by certain kind of disease. Okay, which one is more serious? If you get predicted, okay, you've been positive. Okay, COVID lah contoh. Okay. But actually you are not positive. Tetapi bila you predict negative, but you actually get positive. Which one do you think is serious problem? Which one do you want to have higher accuracy? Okay, position mana yang lebih penting? Bagi saya precision for you have predicted as negative. Okay, tetapi you get positive. So I want to make sure when I predict negative, I want to have that to be higher precision. Okay, compared to the other one. So this is more critical problem. Okay, so that is based on justification. Okay, okay, so I want to show to you another thing. Okay, you still remember the configuration nodes. Okay, I want to configure some of these nodes. Okay, I want to configure this node supaya at least saya nak I want to see okay, I want to configure so that my algorithm will be I will do some experimental dekat sini. Okay, so I can use what we call as kita boleh gunakan satu node untuk optimization, we call as parameter optimization. Okay, mungkin ada yang tak ada node ni. Okay, saya rasa mungkin tak ada, tapi tak apa, you can watch later. If you want to do the installation, you go to file, okay, install KNIME, install ni. Okay, go to here. Okay, sekejap mana dia? Okay, and then search for optimization. Okay, it takes time to download this letter. So, okay, so KNIME optimization extension. So you have to download this. Baru ada dekat sini nanti. Okay, baru dia ada. But I want to show to you how to do this kind of experimental works. So first I will apply this. Okay, parameter optimization. Okay, so you see the variable, we have to create the control variable. Okay, when I connect it here, so dekat sini saya akan adjust the parameters. Okay, so saya akan adjust the parameters here. Okay, so what actually I can do here? Okay, so I want to define a new name of the parameters. For example, min num record. Okay, you can use any other names, doesn't matter. Okay, and then starting value, I want to start with 2 minimum of the iteration. And then maybe I stop at 15 iteration. And the step size I set as 1, and then it must be in integer supaya dia tak ada decimal places. Okay, later I will describe on this. So I use the brute force, means that each of these iteration must be done. Kalau saya gunakan yang high climbing ni, okay, dia akan tengok mana satu. Okay, kalau dia dah mencapai certain number of differences, dan dia terus stop. Kalau brute force, dia akan kira semua iteration tersebut. Okay, so I use a brute force. Okay, so which parameters that I want to configure? Okay, ini yang kita panggil parameters configuration. Okay, kalau tengok sini, saya nak ni number of records per nodes. Okay, contoh saya nak adjust parameters ni. Okay, so number of record per nodes. So I start with 2, nanti saya tukar jadi 3, 4, 5, 6, 7, and then at the end of the day, which one that can give better results? Okay, so I configure this, but I cannot set here. I will use the flow variables. Okay, flow variable kat sini, and then configure min number records per node. Okay, and then use the variable that we already set. Okay, and then click apply. Okay, so because we have this loop start, we also need the loop end. Okay, the loop end will read the parameters from scorer node. Oops. Okay. Apa dia tak dapat bergerak ni? Ya. Okay, ini keluarkan dia punya tu show blah blah blah. Okay. Right. Okay. So the condition to stop this loop is based on what? Apa data yang saya nak collect dekat sini nanti? Adalah I want to collect it based on the parameters that I observe here. So kalau kita tengok dekat sini, data yang saya boleh ambil adalah kalau kita tengok accuracy statistic. Oops, sebab dia dah tak ada tadi, kita dah tu. Salah satu dia adalah accuracy sebagai contoh. Okay, I can take that accuracy. So, for example, nak ambil value apa dekat sini sebagai dia punya objective function. Okay, contoh objective function saya adalah accuracy. The higher the accuracy, I will take that as a value yang saya akan gunakan sebagai number of record. Okay, so click apply and then click OK. Right click and execute. Okay, nampak tak dia akan run berkali-kali. Sebab dia akan test number of record 2, 3, 4, 5, 6 until 15. Okay, so when I right click and then check here, apakah best parameters dia? You see? Okay, the number of record I have to set is equal to 11. And then the accuracy that I can achieve is 84.5%. Okay, this is the highest accuracy that I can achieve. Okay, and if we check back the model that we generated here, okay, so contoh dekat dekat scorer. Okay, So we will get 84.1, which is based on number of record equal to 11. Okay, so position dia adalah bagus sikit dari tadi, 64%. Okay, dan if you see the stay, okay, ada improve sikit lah juga. Okay, the accuracy here. Okay, and you can do a lot of experiment. You can adjust other parameters to do the experiment. As long as you know how to define the configuration here, and then you know which one that you want to test. Okay, ini banyak lagi parameters yang boleh adjust. So ini menjawab kepada soalan parameters malam adalah yang ini lah, baru parameters. Okay, alright. So that is for a classification model. Okay, masih larat lagi ya, ada setengah jam lagi, lama lagi. Okay, untuk kita clustering. Clustering ni tak banyak lah. Okay, clustering ni tak banyak. Okay, so far okay tak? Boleh Okay, ini you guys boleh try and error, a lot of example that you can choose. Okay, and different problem, different things, different way we can use to different algorithm, different setting, different parameters there. Okay. Alright. Okay. Okay, boleh tak saya continue? Ini sikit dah lah. Ini clustering tak banyak lah. Okay, clustering kita try to understand what is the model about. Okay, and then later on we will do the example also. Okay. Okay. So you see, yang first ya. Okay, you guys ada tak yang ni tadi? Ada tak note yang ni? Ke tak ada? Can I get the ni? Tak ada Oh, ada yang ada. Oh, ada. Okay, oh ada yang tak ada Okay, ada. Mungkin ada tu mungkin dia dah install Kalau tak ada, you have to go here and then search for the install and then type optimization. Oh, dah ada Okay, kalau tak ada, you have to install the VR here. Okay, install KNIME. Okay, saya tunggu dulu. Saya tunggu dulu bagi yang nak install. Okay. So here dia dekat sini. Okay, type optimization. So sometimes you have to restart again later. Yang ni. Okay, so bila ada ini baru dekat kita punya mining punya group node nanti. Okay, dekat mining punya group node. Okay, go to analytics, go to mining, dia ada group node optimization. Okay, ada group node optimization. Okay, alright. Mungkin kita rehat 5 minit, okay, while we waiting for some others maybe tengah install. Kita rehat and then 10:40 lah kita sambung balik. Okay, I think this is not much. Okay, this is not much. I think within 30 minutes I can finish. Okay, kita rehat jap. Okay. Okay, so we continue a little bit. Okay, kita continue lagi, right? So this one doesn't take a lot of time. Okay, it's a pretty straightforward. Okay, so you see here the first problem that we encounter when we want to develop machine learning is more into a supervised learning, right? Okay, why it's called a supervised? Because we already know the response. Okay, maksudnya when I want to predict the price, in my data set, I already have a price there. Okay, so when I want to predict the status of the churn, okay, the exited status, I already have that column. So my model try to match the possible input into the output column. Okay, and then it will learn through that appropriate algorithms. Okay, so in clustering model, so it's more into an unsupervised learning algorithm. Okay, but some of the problem they call it as a clustering supervised model, but I'm not agree with that, because what I say, if there is any, okay, if there is if you already know the response, okay, and you knows how to class that the algorithm, let's say you're able to class the observation, so that is a classification problem because you already know the class already. Okay, clustering is to identify what is the class, the possible class. Okay, and we don't know yet. Okay, so it's more on unsupervised. If you already know the class, you want to predict the class, that is more supervised learning, and that is classification problem. Okay, understand? For example, okay, so clustering is more into, we want to define a group of people that share the same characteristic. Okay, so we must understand what are the characteristics that we want to group them. Okay, maybe we want to group of people, we want to have a cluster of people. Okay, for example, they like a movie A and B, but some people, they don't like movie A and B. So you see there is a two group of people there. Okay, and how do we measure it? Based on their rating. Do they like that movie? Okay, so rating here is the success metric to measure, okay, this kind of so if this is the goal of data science now. Okay, most of people sometimes they stop, oh, I already predict I already predict the price, I already predict the churn. Do you know why they churn? What are the characteristics of people that are churn? Sometimes people based on demographic, oh, because he is from France, because he is a man, for example. Okay, because he has this salary, this estimated salary. So that is demographic. So in actual, we have to go beyond that. So in NAPSOft, we call our methodology, we call as a NAPSOft way. Okay, we have to go beyond that dimension into more deeper dimension. So that deeper dimension can be implicit. Okay, it's not something that explicit. It's more implicit value, holistic value. For example, in this case, okay, and another things we can observe that, for example, the fruit cases. Okay, sometimes people just measure the dimension. Okay, what's the diameter? Why not we try to take a look into a different perspective, maybe based on shape, based on color. Okay, so a lot of things are. So this is, if you go here, okay, you have to know what is the measurement metrics to define the success of the event. Okay, so that is more into a deeper analytics level. Itu adalah satu core of knowledge where you apply all this knowledge into a certain extent of application. Okay, dan itu baru dia nih, the real data science punya job. Okay, it's not limited into, oh, I already predict the model, ini model. Okay, So, and then the next level to show why it happened. Okay. All right. So these are example lah, customer segmentation, social network analysis, city planning. Okay. So I'm not sure if you, saya rasa semua kita dah tahu kot tentang Cambridge Analytica where they use the profiling of the data or the people data, okay, to understand the behavior, okay, to understand the characteristic of the individual, okay, based on ocean model. Okay, so kita pun ada guna ocean model, okay, sama ada that individual is openness, okay, C conscientious, alright, apa lagi, okay, dia ada 5 traits of this characteristic. Saya dah order satu buku, saya lupa tajuk dia, based on this. Okay, so you see here, for example, kalau kita tengok dalam data set ni, dia ada 2 measure metrics that we use. First is based on annual income and then spend score. Okay, spend score ni kalau kita tengok dia bukan based on spending 1,000 sebulan, 2,000 sebulan, bukan, dia based on scoring dia. Okay, so maybe they define if you spend between 1,000 per month until 5,000 a month, okay, your score is 1. If higher, then you are higher. Okay, so based on this, kita boleh define satu characteristic of this customer. Whether they are standard customer, okay, careful customer, okay, careful customer. So you see, dia banyak income tapi dia tak spend banyak. Okay, some of people they are careless. Yeah? Wah, income sikit tapi spend banyak. So we define them as a careless customer. Okay, so this is properly determined by the expert method. Okay, banyak shopping online. Okay, so ini adalah we say as an expert method in business. Okay, in that business problem. Okay, sometimes if we as a data science consultant, if we do, even us, if you do consulting work with others, we need their opinion. They know more about their business. Apa yang kita boleh buat, kita create, okay, in this, how do we want to measure? Boleh tak kita group? Itu yang kita boleh suggest. Tapi at the end of the day, dia tahu tentang business tu. So there must be a better communication between two individuals. Two parties lah. Okay, so dia tak boleh, oh, data scientist cukup, data analyst seorang, ya, untuk buat all these thing, susah. You have to have a business domain dekat situ. Unless if, for example, me from civil engineering, if anything about concrete, I already easy for me to understand because that is more into my domain. Okay, ataupun something related of marketing, boleh lah. Okay. So that one is easy subject matter, so it's easy. But if we go to another field, medical, for example, is very difficult lah. So itu memang difficult. Okay. Alright. So how good is, okay? Long time ago use KNIME, yeah. Oh yeah, ada guna untuk gene expression, KNIME clustering, Okay. So how's the result? Okay, boleh lah, can get some findings from there. Okay, long time ago, boleh, it's good, okay. So ada dikit juga guna KNIME juga lah nanti. Okay, kalau dah lama memang lupa lah, Okay, Akmal is from bio background or what, Akmal? Yeah, biological background. Bio, Oh, bioinformatics. I see. So you see the KNIME here. Actually, dia banyak buat tentang bioinformatics, you know. Okay, actually most of the developer dekat KNIME tu, saya pun ada kenal, mereka dari bioinformation punya people. Okay, so they are very, even they do the extraction of the literature review tentang bioinformation pun dia guna KNIME. Okay, so it's very, actually there are a lot of some example you can find internet ataupun dekat YouTube about bioinformatics using KNIME. Ada. Okay, ada. Okay, yes, bioinformatics. Yeah. Okay, so how can this clustering can be useful in business, for example? Okay, so kadang-kadang dia jual products, okay, dulu madman punya generation, madman, okay, so that time they just do a blast marketing. Okay, I think that is 2000, not 2000, sorry, tahun 60-an, 70-an. Okay, so TV itu everything dia tunjuk iklan kat situ. Okay, nowadays, okay, if we do like that, due to a lot of competitors, we will spend a lot of money into that advertising, which is very waste of money lah. Dan mungkin orang yang tengok iklan kita tu tak berminat. So that's why nowadays, okay, kenapa Facebook ataupun others, so Facebook lah the most successful social media for marketing. Sebab dia guna target marketing. Okay, if you do the targeted marketing using Facebook, dia boleh identify interest. Sebab kita dah ada profile. Okay, individual ada profile dekat Facebook already. Okay, so when you have this idea of this cluster of people that will buy your product, ada chance beli, bagus you target marketing dekat group people ni. Instead of mass marketing. Okay, you reduce the cost, but you increase your profit margin. So itu yang paling penting. Okay. Alright, so one of the algorithm, dia ada banyak, ada DB scan, ada hierarchy punya algorithm. So one of the most popular is K-mean clustering. Okay, the concept is very easy. Okay, so to define the cluster, which one that belongs to each other, is by using this mathematical model. Don't worry, I'm not going to explain more about this in detail. Saya hanya tunjukkan dia punya konsep sahaja. Okay, so in order to show that concept, allow me to open my slideshow as usual. Ya, buka slideshow kejap. Mana dia? Okay, dekat sini kot. Dekat sini. Okay, beda. Okay, this one. Okay, so let's say we have this scatter plot. Okay, how's the k-means work? Okay, so initially what you have to define, of course, katakanlah saya rasa saya tengok je saya tahu ada dua cluster that can be derived from this. Okay, so these are the things that I can tell from this graph. Okay, ada dua cluster. So I define the number of cluster. So the first thing, I choose the number of cluster. Katakan 2. And if I have 2 cluster, then I have to place the centroid. Okay, to place the centroid supaya nanti dia attracted. Ini pernah dengar black hole. So black hole tu dia, if you near to that, dia akan suck. Okay, go inside there. So samalah centroid tu macam tu dia punya konsep. Okay, so centroid tu sepatutnya center of the cluster. Okay, so in this case, you cannot define it properly yet. So the model have to suggest the location of the centroids initially. So this is the initial location of the centroid. Okay, and it will be determined randomly. Okay, and then the second is it will try to capture the data point that nearest to that centroid. Okay, so ini yang paling nearest to here, ini yang paling nearest. So ini saya tunjukkan yang 3 ni. Ini pun nearest juga lah sebab saya nak avoid kind of sophisticated line there. Okay, so you see the nearest will be connected to each other to map with this centroid. So when it already been mapped, the next stage is to define the new location of the centroid. Sebab the term centroid dia kena tengah-tengah. Center of the ni. So kalau kita tengok kenapa dia move sini, sebab dia concentrate banyak sini. So possible of the centroid happen here. Contohlah, ini contoh. Sama juga dengan ini. So bila dia do the another iteration, So dia akan recompute back untuk cari. Sekarang ni tadi dia belong to this cluster, tapi sekarang belong to this cluster. Okay, because they're near to this centroid. And how they measure the distance is based on square Euclidean distance. Ini dia punya konsep. Okay, menggunakan square Euclidean distance. So, and then what happen next adalah dia akan define a new centroid location baru. Dia akan bergerak ke tengah-tengah. So, means that when we calculate the average of the center, the location of this centroid, dia adalah paling tengah lah. Okay, dia adalah mewakili tengah-tengah of this. Okay, of this data point. Right? So, then dia akan cuba untuk cari point lain, tapi in this case dah tak ada dah. Okay, maksudnya yang paling near already been captured. Okay, so at that time it will stop. Okay, dan dia dah membentuk dua cluster lah. Okay, these are the things happen. Okay, alright. So that is about using this slide. Okay. So kita nak gunakan ni balik. Okay. So how that's how it determine. Okay. Sekarang ni dulu bagi yang pernah join saya punya course Python, kita nak determine number of k, right? So the number of k kita determine sebelum ni adalah menggunakan apa teknik? Menggunakan the elbow method. Okay, dekat KNIME ni dia tak ada satu nodes yang represent yang memang untuk elbow method, tak ada. Sebab you see the elbow method even dalam kita punya programming kita kena create sendiri function tu. Okay, do a multiple of iteration. Okay, so in this case ada satu lagi shortcut. Okay, the way to validate the performance of the K-mean clustering menggunakan silhouette coefficient. Okay, so dia adalah digunakan untuk interpret and validate the consistency. Okay, adakah data ni belongs to this group? So dia ada silhouette coefficient dia nanti. Okay. So it range from -1 to 1. Okay, high value indicate that data point is well matched to each cluster. Okay, nanti kita akan tengok the measurement. Okay, so the matrix this the distance is also using a Euclidean distance. Okay, all right. So without further ado, we just straightforward to do this example. Okay, so you see here the data set that we have. Kita ada dua, satisfaction of loyalty. Okay, so this is the metric measure of success. Okay, ini adalah metric measure of success. Dia bukan lagi macam demographic. Okay, macam gender, macam age, macam salary. Dia bukan demographic anymore. Dia more into a metric success. Okay, untuk hierarchical clustering. Silhouette coefficient boleh guna untuk hierarchical clustering tak? Dia kurang sesuai untuk hierarchical clustering. Okay, hierarchical clustering dia ada dia punya measurement sendiri. Okay, so silhouette dia ada satu. Saya pun dah lupa hierarchical clustering. Maybe later I will share in the Google Classroom. There is a one method. Okay. Hierarchical clustering dia ada satu tu parameters yang dia measure, and I forget on that already. Dia ada satu parameters, ya. And later I will share with you on that part. Okay, right? Dia ada satu parameters tu. Okay, okay. Nanti I will find that in the books, ya. Okay. So in this case, okay, kalau kita tengok dekat sini, the dual. So I cannot deduce that you satisfy and loyalty. Okay, maksudnya tak semestinya you satisfy to the services, you are loyal, as I mentioned earlier. And tak semestinya you loyal, you satisfy into the services. Okay, so the first, if we want to start our works, we have to visualize the data. Okay, visualize the data. Okay, yeah. So the data set that we are going to use is segment, customer segment lah, ya. Okay, so CSV file. So import that CSV reader. Okay, import this CSV reader. Okay, look for the machine learning and then customer segment. Okay, customer segment. Both data is in either integer ataupun double. Okay, tak ada row ID, so import it as it and then execute it. Okay, as usual kita nak tengok trend dahulu. So nak tengok trend kita gunakan scatter ya. Scatter plot. Okay, nak tengok trend kita kena gunakan scatter plot. Okay, so drag this scatter plot and we want to see the trend of the data set. Okay, katakanlah x-axis I use satisfaction and y I use loyalty. Click OK and then execute it. Okay. From here, I cannot see any linear relationship. Okay, sebab satu dia adalah metric measure, as I mentioned earlier. Okay, success metrics dia bukan demographic. So tak ada relationship semakin satisfied, semakin loyal, tak ada. Okay, but I can see here, if I want to plot this, I can visualize it into 2 quadrant. Ada 4 quadrant yang saya mungkin boleh dapatkan insights from here. Okay, so saya lupa masukkan ni dalam slide ni. Sekejap ya. Sekejap. Okay, so from here we need, that's why we need to have the business domain. Okay, the business domain is very important. Okay, so saya terlupa ambil dia dekat slide ni. Sekejap ya. Satu slide, I forget to put it here. Okay, wait ya. Okay, this one. Okay, so if you know the business domain already, okay, so you see I can map them into 4 quadrant. Okay, ini ada 4 quadrant to define the behavior of the individual. Okay, so the first quadrant here adalah yang bawah ni adalah yang low satisfaction and low loyalty lah. Maksudnya dia tak satisfied. Okay, and then this may be the high satisfaction but low loyalty. Okay, ini adalah low satisfaction, okay, high loyalty and high satisfaction and high loyalty. Okay, but I'm not sure whether maybe boleh jadi 5, kita tak tahu. Okay, but that's why we have to measure what is the number of cluster that's suitable to define it. But initially I have this idea. Okay, so later on we are going to test whether is it true that I can clustering that based on these 4 quadrant. Okay, 4 quadrant of characteristic. Okay, so kalau kita tengok scatter plot ni, okay, macam boleh lah. Okay, it seems possible. Okay, so I can make it something like this later on. Okay, so we want to do that. So how do we do that? Okay, and open this one. Okay, so how do we can start to delete? Okay, so another things that we can perform here adalah first, if dia lain sikit daripada machine learning sebelum ni, sebab data satu dia simple je like this. So as you can see, apa benda yang kita kena buat dulu? Nak buat transformation tak perlu. Okay, dia tak ada missing values. Katakanlah, okay, so you see here, dia tak normalize, right? Okay, so I have to normalize the data set. Okay, I have to normalize it first. Okay, so we have to do the normalization. Okay, so normalize the data set. Okay, this is pretty easy. This is quite easy. Okay, so loyal. Okay, I use a min max. Okay, the most simplest form. All right, so after I get the normalized value, so I will get this kind of data. Okay, ini dia punya normalized value. Okay, So later on, I want to observe the distribution of the data. Okay, so how can I cluster this? Okay, is it belong to cluster 1? Is it belong to cluster 2? Okay, how do I can do that? Okay, how to do that? Okay, so we can apply K-mean clustering. K-means clustering. Okay, so in this, nampak tak dia ada banyak lagi tau dekat clustering ni. So salah satu K-means, and then we have another hierarchical. Okay, kita ada DB scan, right? So this one I use a K-mean. Okay, so apply it into a K-mean here. Okay, and then okay, ini adalah number of cluster. Okay, ini adalah number of cluster. Okay, so katakanlah saya nak start dari 2, number of cluster. Okay, and then I use this one. Ini jangan, nanti saya ajar how to use this flow variable. Okay, still remember the flow variable that we have before. Okay, so the next setting that we can adjust, okay, static random seed we set at 0. Okay, so we use random initialization, tak ada masalah, supaya dia boleh letak randomly the centroid tu nanti. Okay, and then click apply. Okay, execute and open view. So here they will give you summary. Okay, paling best kita tengok dekat label input ni. Okay, untuk data yang pertama ni dia belong to cluster 0. Data yang kedua dia belong to data. The cluster will start map with 0. Okay, start map with a 0. Okay, so I want to visualize this table. Okay, saya nak visualize this table. Biasa kita nak visualize this table. Okay, so in order to visualize this table, I can use, okay, scatter plot. Scatter plot. Cuba kita gunakan scatter plot. Type it here and then drag it here. I believe we will not get the answer. Sama je dengan yang previously. Correct? Okay. So kita kena add dia punya indicator. Okay, and indicator tu sama ada color ataupun shape. Okay, katakanlah saya nak gunakan color indicator. Okay, so kalau cluster 0 dia warna biru, kalau cluster 1 dia warna merah, something like that. Okay, so I use color manager. Okay, dekat view ni under properties dia ada color manager node. Okay, ada sebelum ni tanya saya tentang color as a input. So biasa kita gunakan color manager ni untuk configure. Okay, to configure this view node. But make sure we already know the properties of the clustering. Okay, so you see the clustering, nampak tak? Dia tak ada validation menggunakan train and test set. Sebab kita tak tahu output. Macam mana nak buat train and test set? Test set nak apply, tengok apa? Kan, betul tak? But what we can do is, that's why we have to measure using silhouette coefficient. Okay? Excuse me. So, gunakan color manager ni. Okay, and then kita ada dua cluster kan tadi. Okay, I want to name it based on cluster. So, kalau cluster kosong, okay, dia warna hijau, cluster 1 dia warna merah. Okay, and then right click, execute and open view. Okay, so nampak tak dekat sini, ini hijau, ini merah. So that cluster will be divided in this way. Okay, this cluster will be divided in this way. Okay, right. The next thing is to determine the performance of the model. Okay, so kita kena gunakan apa? Silhouette coefficient. So search for silhouette coefficient dan dia memang under scoring lah. So dekat scoring node tadi kita ada numerical scorer, dia ada scorer node dan dia ada silhouette coefficient. Okay, dia ada silhouette coefficient. Okay, so drag this silhouette coefficient and configure. So from here ini tak mau ini tak mau. I don't. Saya rasa dia kena tarik terus daripada ini saya rasa. Okay, wait ya. Let's see the configuration here. Okay, dia sepatutnya ada dua sahaja, and then we want to define a by cluster. Okay. So run that silhouette coefficient. Okay, and then see the mean. Okay, ini yang paling penting. Okay. So the higher the value, the better the model. Maksudnya karakteristik dia memang ini betul-betul strong karakteristik. So maksudnya ini 0.52 and then I got 0.462 overall for this cluster. Okay, so I already test. Okay, nampak ini macam dia saya rasa sama kot saya dapat. Okay, lebih kurang lah, lari sikit lah, lari sikit. 52. Okay, so dia lari sikit, so 441 sama. I think sama lah. 422 sama. Okay, sudah pukul 11 ya. Okay, boleh lagi ya tuan-tuan, sekejap lah. I think 20 minit lagi, boleh ya? Okay ya. Okay, sekejap minum air sekejap. Okay. Okay, data pun kita tengok benda yang sama macam the lain. Okay. Okay, alright. So we continue a little bit. Okay, continue a little bit. Slow. Okay, slow. Nothing to rush. Okay. So in this case, let's try to observe. Okay, what happened if the k value equivalent to 3? Okay, katakanlah k value equivalent to 3. So silhouette coefficient, kita run lagi sekali. Okay, and then result table. Okay, so you see if result table dia akan, okay, ini belong to color merah, maksudnya dia adalah under cluster 1. Okay, cluster 2. Okay, all this will be given there. So let's take a look into the mean. Mean ni yang paling penting. Okay, kalau kita tengok mean dia overall 0.421. Okay, cluster 1 dia lebih strong to define each together. Cuba kita observe scatter 1. Cluster 1. Okay. So cluster 1 is yang warna merah, so ini. So maksudnya dia lebih dekat antara satu sama lain. This one. So they are strong together. Okay. And then let's try to visualize if okay, kalau kita tengok when I increase this, the overall value will be increased. Betul tak? Nampak tak? Ini overall dia 0.462. Okay, the mean silhouette coefficient dia, the overall is 0.462. Then when I increase the number of k, dia akan naik juga 0.421. Okay, when I increase again, dia akan naik juga 0.484. And kalau saya naikkan lagi, dia dah turun dah 0.382 overall. Okay, when I increase, some of the coefficient increase, some of them reduce. But in overall, it shows the reduction of the mean silhouette coefficient. So means that the optimal amount of k from here, I can say is a 4. It's the best. Okay, to have a this one. Okay, so this one match with the inception with the our inception our idea initially to have a 4 quadrant, okay, of the data, of the characteristic for this data set. Okay, so we have 4. So katakanlah saya adjust 4. Okay, so run it and execute. So we will see the scatter plot this way. Okay, so ini adalah group 1, okay, group 2, 3, and group 4. Okay, so we can cluster that. Okay, satu lagi saya nak ajar. Ini kalau ini kita kena tukar input kat sini kan. Let's say I want to use kita nak gunakan configuration node. Okay, configuration node. So you know that the value here is integer value, betul tak? So saya boleh gunakan integer configuration. Okay, do you under configuration and input group node. Okay, so I can use integer configuration. So here I can create, okay, maybe label enter number of cluster. Okay, so katakanlah ini cluster input. Okay, so minimum value ini tak perlu, mungkin I can set default value as 2. Minimum value saya pun boleh letak 2. Okay, and then click apply, and then apply this variable into this node. So in order later on kita tak read input dari sini, we don't care about this. Okay, we read input from that configuration node. Okay, so click OK and then apply. All right, so next time if I create the component, saya boleh gunakan ni. Okay, I can use this to create a component. Okay, contoh nanti kita tengoklah Okay, so I adjust here. Katakanlah sini 2. Okay, so saya groupkan dia jadi satu group kat sini, ataupun groupkan sekali dengan scatter plot. Ini cantik. Okay, kita create component and then clustering. Oh, sorry. Okay, kita create component clustering. So dia jadi satu component. Okay, so silhouette coefficient tak apa, kita boleh letak luar, tak ada masalah. And then I can enter. Okay, saya nak number 4. So right click, execute and open view. So I always can give this kind of. Okay, ini 4 cluster. Okay, so saya nak tukarlah 2 je. Okay, so I can use this. So dia akan generate 2 cluster. Okay, so we always can change that. So ini memudahkan kita punya kerja lah. Itu tujuan dia component. The component. Okay, the component can be created using configuration node, using widget node. 2 ni boleh untuk create a dialog. Okay, ini adalah dialog tadi. Okay, ini adalah dialog punya dialog punya tag. Okay, alright. So let's try to understand the result that we have. Okay, kalau 5 nampak tak dia dah jadi lain. Tengok ini pun kenapa dia ini macam mana nak define this group. Okay, susah nak define ni. Okay, right, best kan? Kan senang guna ni, dia simplifiedkan proses actually component. But of course if you want to design dia agak susah dulu mula-mula. Tapi once you understand, dia nampak macam senang sikit lah. Kalau component. Okay. So you see number of need 4. Okay, so this is more into a customer segmentation. How do we define? Okay, so biasa kita akan name that cluster. Okay, kita tak boleh cluster 0, cluster 1, cluster 3, cluster 2. Okay, so we name that as the base name to define that characteristic. Okay, contoh cluster ni yang dia satisfy, dia loyal. So ini kita punya fan lah. Okay. Can we also use parameter? Yes, can. Maybe we can try. Kita cuba. Ya, boleh kita cuba. Okay, so here expand dia. Okay, kita explode dia sekejap. Okay. Kita cuba. Okay, kita cuba. So ini mungkin okay, kita cuba ini tak perlu. So kita cuba gunakan yang ni. Kita cuba saya cuba dulu. Okay, drag it here. Drop it here. Then I know the end condition will be based on the mean silhouette coefficient, right? Okay, kita cuba dulu. Okay, I name this as a cluster. Supaya lebih senang. Okay, I test one by one, blah 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 blah. Okay. Okay, and then it must read. So the control variable here, it read cluster. Okay, and then click OK, and then click apply. Okay, and then here we'll read. Oops, dia tak boleh tarik di situ ya. Okay, this one I want to choose overall mean silhouette coefficient and maximize. Click apply and then let's try. Maximum berapa tadi? Maximum kita ada set tak? Oh, ini banyak sangat nih. Mungkin kita katakan 6. Let's say 6. Okay, and then execute. Blah 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 blah. Oops. Okay, best parameters. Masih dia cari 4. Okay, so we also can use this. Okay, as a way to communicate with the apa nama ni? Yang ni tadilah. So kita boleh gunakan itu juga. Okay, boleh ya? So this is more an experimental lah. Kalau nak determine the number of best cluster. Okay. Alright, mana tadi? Okay, boleh ya? Okay, Carol, I hope that answering your question. Okay, easy ya, easy. As long as we understand, it should be easy later on. Okay. So yeah, we have to name it properly. Okay, so for example, cluster 3 here. Okay, they satisfy but they are not loyal. Okay, macam kadang-kadang saya lah pergi travel tempat lain. Sedap. Okay, mana-mana kalau sedap tapi tak selalu datang sebab kita tak di situ. Okay, so this group of customer maybe they are traveler. Okay, traveler customer contoh. Okay, and supporters. Okay, kenapa dia mungkin supporter dia tak satisfied tapi dia loyal. Okay, supporters mungkin no choice for example. Okay, alienated. So maksudnya ini adalah group yang memang dia tak suka lah. Okay, dia tak satisfied dan dia tak loyal lah. Okay, dia mungkin sekali-sekala. So these are the things that we can try to understand, give the right naming. Okay, and then we can perform a strategic communication. Okay, how do we deal with this group of customer? Okay, so maybe if we understand the customer supporters, okay, so for example, we conducting a survey. Okay, ataupun kita tengok apa barang yang dia selalu beli. Okay, so we want to turn them from a not really satisfied customer into a satisfied customer. We want to, okay, ini kita boleh kata ada yang atas pagar. Okay, we can convert them into a fans. Okay, but what are the things that they need? So we have to do the survey to targeted group of these supporters. Okay, so mungkin dia loyal, tengok apa benda dia beli. So we provide discount so that dia boleh rasa satisfied. Ataupun mungkin dia buy that product, dia loyal, then why not we introduce a new product that much better than this can improvise his satisfaction. Okay, so these are the things that more into a marketing lah, the way we communicate, okay, with the clients. Okay. Alienated ni kadang-kadang kita tak boleh buat apa. But the most important thing, kita tak nak this convert to this group. So we will have to maintain them. And sometimes we pun boleh measure berapa persen mereka ni gunakan match rule. How many percent of them are cluster as alienated? Okay, berapa persen mereka? Adakah dia consider banyak? Macam 25% quite banyak juga. Okay, but of course we want to reduce the amount of this amount of this group of people lah. Okay, so roamers, so we have to understand roamers the behavior macam mana. Okay, the roamers category can be a traveler, for example. Okay, and then when we go deeper into this individual characteristic of these people, contoh saya, I go to KL and then I stay at this hotel. So this hotel near to this restaurant. So I will always go to that restaurant because I go to hostel and because I go to this hotel. So what happened if hotel ni mungkin tukar ke and I maybe try to find another hotel which is farther than this. So kita boleh cari reason why this customer, which group of this customer from based on location. Okay, so ni penting juga lah. Okay. And then roamers ni mungkin kita boleh buat royalty program. Okay, sebagai contoh, if let's say kita Shopee, Shopee ke ataupun whatever website that we buy purchase item, okay, so kita boleh gunakan membership program, discount offer supaya daripada dia satisfy, dia boleh jadi loyal, selalu beli dari situ. Okay, bukan sekali je. So ini adalah more into a program, okay, marketing program, okay, right? Ya, duty free, ya, boleh dapat free shipping. So that is a kind of things to improvise the customer loyalty, okay, and the satisfaction. Okay, parameter optimization can be used for any algorithm. Okay, so a good question. Parameter optimization. So you have to know parameter apa yang kita nak optimize tu. Okay, contoh tadi, kalau if I go to algorithm linear regression ni, kita tengok ada tak parameters yang kita boleh optimize ni. Nampak macam tak ada kan, so dia tak sesuai dekat sini. But if we go to logistic regression, contoh mana logistic regression, okay, here. So logistic regression ada banyak parameters, okay. If you go advanced, okay, learning strategy, ini selection saja parameters ni. Banyak yang involve number. Okay, contoh step size 0.1. Okay, so maybe I want to try a few step size. So I can choose that step size mungkin daripada 0.1, then later on I test 0.01 or 0.001 boleh. Okay, so make sure you understand, ini kita panggil parameters lah. Okay, so in this case, as long as you have parameters that existed in this algorithm, you can use that. Tapi kalau macam regression, tak ada lah, dia tak ada. Okay, boleh ya? Alright. Okay, so next, finish.